What does survival sound like after the world forgets its giants? What does life sound like when silence follows an apocalypse so absolute that continents still feel the echo? This is not a story about spectacle. It is a story about the slow, patient work of filling a vacuum, about the subtle art of becoming when the stage is swept clear and the curtain lifts on a world that has been given, by accident and cruelty, a second act. When the great surface of the planet cooled after the cataclysmic finale of the dinosaurs, the continents were a mosaic of ruin and possibility. Ash and dust had smothered sunlight. Forests had knuckled under to new climates. Coastlines had rewritten themselves. In that aftermath, the ecological script was blank. The visible rulers of 66 million years, the thundering saurian dynasties, were gone. What remained were small, warm-bodied creatures tucked into the margins, tiny mammals, often no larger than a modern rat, mere flickers in the deep tapestry of life. To call them survivors is to understate their circumstance. These were life's refugees, carrying ancestral habits like talismans and obligations to an uncertain future. The early mammals did not stride in the sunlight with obvious conquest. They crept, burrowed, fluttered at the edges of vision. Many had been nocturnal long before catastrophe, a life shaped by evading dominant diurnal predators. This nocturnality became a fortress. Night offered cover. Small size, once a liability under the shadow of giants, became an advantage in a world newly scattered with dangers and opportunities. The small mammals' biology fur, endothermy, rapid metabolisms, allowed a different tempo of life. A faster heartbeat, higher energy, the ability to forage when cold nights might have immobilized reptiles. In the hush of the post-impact world, those quick pulses were everything. Adaptive radiation is an elegant phrase for a chaotic experiment. Faced with empty niches, life, fragment by fragment, tested new solutions. The small mammals spread into roles that had been unthinkable when predators measured in tons patrolled the plains. Burrowers tunneled into the dark soil, their colonies becoming microcosms of social life and thermal stability. Arboreal specialists took to the trees, developing grasping hands and limbs that could negotiate a three-dimensional landscape. Aquatic niches, shallow coastal waters, the creeping margins of wetlands all drew in lineages willing to tinker with teeth, fur, and limb arrangement. Tooth shapes diversified, incisors adapted for gnawing, molars evolved complex ridges for grinding plant matter. Diets shifted from insectivory to omnivory, herbivory, and carnivory, and with each shift the shape of bodies followed like a shadow. There is a particular, almost cinematic scene that recurs in the fossil record, an unremarkable forest floor under a thin, cold moon. The detritus-strewn litter is alive with motion at scales invisible from a human vantage. In this repeated tableau, one sees the evolutionary dramas playing out, tiny snout centers probing for insects, small eyes reflecting starlight as they register the faintest movement, paws that probe and scrape. There is no singular protagonist, rather there is a chorus of traits being tested and selected. The night is a laboratory in miniature, with predators and prey engaged in a slow game of concealment, detection, and escape. Natural selection acts less like a sculptor with intent and more like wind-shuffling shapes in sand, persistent, directional, indifferent. The emotional tone of this epoch, if one may call ecological tendencies emotions, was a mix of acute caution and relentless curiosity. Caution because any misstep could be fatal. The difference between warmth and exposure, nourishment and starvation, life and oblivion was microscopic in such fragile bodies. Curiosity, because where power vacuums open, information becomes currency. Sensory systems refined accordingly. Olfaction, hearing, and tactile sensitivity intensified. In some lineages, vision began to take on a new importance as daytime niches reopened and canopy light patterns favored depth perception and color discrimination. The very idea of looking evolved from simply detecting movement to parsing environment for tool use, manipulating objects, understanding graspable surfaces, learning to foresee consequences. Such changes were incremental, but over millions of years they stacked up like geological strata, creating cognitive scaffolding that would, in deep time, enable minds that could think about thinking. Parental care, a quiet form of evolutionary investment, became profoundly consequential. Mammalian lactation, an intimate physiological innovation, allowed offspring to be nurtured in ways that reduced dependency on scarce external food sources. Neonates could be born underdeveloped and rely on prolonged care, creating space for extended learning. This extension of juvenile periods, combined with the need to learn complex foraging behaviors or social rules, pushed cognitive demands upward. Sociality in small groups generated selective pressures for communication, recognition, and memory. The bonds between kin were often literal lifelines. Parental strategies shaped not only immediate survival, but the evolution of learning and culture in its most rudimentary forms. Continents were not idle spectators to these biological experiments. Plate tectonics continued to jostle habitats, isolating populations and setting the stage for divergent evolution. Mountains rose, rivers changed course, sea levels fluctuated. Geographic isolation was the crucible in which new species emerged. Marsupials, for instance, came to prominence in places like Australia, their reproductive strategy shaped by isolation and the particular pressures of their environments. In other regions, placental mammals expanded with a different suite of reproductive investments and developmental trajectories. The separation of lineages by oceans and mountain ranges was both literal and metaphorical. Each landmass became a distinct theatre for evolutionary improvisation. Plants, too, participated in this renaissance. The explosive diversification of flowering plants during the Cretaceous and continuing into the Paleogene rewired ecosystems. New diets were available: seeds, nectar, leaves with new chemical defenses. Insects co-evolved with those plants, and mammals adapted in response. The relationships between flora and fauna were dynamic feedback loops. Changes in one produced ripples in the other. Forest structures altered light regimes, which in turn favored certain locomotor and sensory adaptations among mammals. Open grasslands later emerged, their adoption requiring different body plans, cursorial limbs for running, energetically efficient digestive systems for processing tough vegetation. Predation pressures shifted in subtle but profound ways. Where the dinosaurs had been apex predators shaping continents, the new top-down forces were different in scale and method. Small mammalian carnivores developed stealth and bite specialization rather than sheer mass. Some lineages evolved into pursuit predators, others into ambush specialists or opportunistic scavengers. These arms races were not dramatic in the cinematic sense. They unfolded over millennia with teeth and claws as punctuation marks in the silent ledger of survival. Each innovation, each incremental improvement in speed, stealth, or cognition altered the balance between predator and prey in innumerable microhabitats. Chance played a colossal role. The evolutionary trajectory from shrew-like mammal to primate to hominin is not a straight line of inevitability, but a contingent path threaded through accidents, meteor strikes, volcanic eruptions, a land bridge forming at just the right time, a climate oscillation that favors a particular adaptation. In this way, the epoch after the dinosaurs is a study in contingency. Small events could cascade into epochal changes. The fossil record is punctuated with such contingencies. Sudden extinctions, radiations, and migrations that could not have been predicted from the start. The narrative, therefore, is at once fragile and resilient. Fragile because it can be reset by catastrophe, resilient because life's inventiveness continually finds new ways to fill space. There is also an aesthetic to these slow revolutions. The mundane transforms into the marvelous when viewed on the timescale of deep time. A forest evolving a new canopy architecture seems like choreography across generations. A burrow system becomes a micro-architecture of temperature regulation and social interaction. The sensory world of mammals, rich with scent-marked trails, ultrasonic calls, and tactile maps, creates ecological tapestries invisible to most eyes but decisive in evolutionary outcomes. These sensory worlds cultivated mental maps, mnemonic habits, and eventually rudimentary cultures, shared behaviors learned and transmitted across generations. The arc of cognition lengthens through this period. Brain size relative to body size grows in certain clades, but more importantly, neural organization becomes complex in ways that support flexible behavior. Problem-solving moves from instinctive routines to strategies learned through interaction and imitation. Here, there is no heroic leap, no instant awakening. Thoughtfulness is an accumulation of adaptive responses that favor foresight, anticipating where food will be, predicting ephemeral weather changes, recognizing kin and social partners. Such capacities set the stage for later developments: tool use, dual-handed manipulation, and social reciprocity. Each small adaptation lays another block in an emergent architecture for intelligent behavior. Yet the prevailing sentiment is one of humility. The scale of time renders these transformations almost anonymous. The mammals of the Paleogene are not characters in a human drama, but participants in a planetary process. The narrative tone should instill a sense of smallness, how fragile, how contingent, while also imparting wonder. That from such modest ranks of survivors, the scaffolding of complex minds would eventually be constructed. This is the paradox that dominates the epoch. From the tiniest, most vulnerable organisms, the potential for expansive cognition begins to be realized. And there is, in the background, an unspoken suspense. Could the same chain of happenstance that favored mammalian success have broken at any point? The answer is yes. The history of life is a history of narrow margins. A different volcanic season, a different sea level change, or the prolonged dominance of a surviving reptilian lineage could have steered the course away from the innovations that led to primate cognition. That sense of contingency imparts urgency to the tale. Not that today's path was inevitable, but that it emerged within a narrow corridor of possibility shaped by selection, geography, and chance. As the Paleogene unfurled, traits that would later be recognized as precursors to thinking, humans accumulated quietly. Increased reliance on learned behaviors, social complexity that favored communication, manipulative hands capable of refining grasp and release, and neural investments that supported memory and planning. For millions of years, these were incremental, almost invisible changes. They were not conscious goals, but consequences of survival pressures and the availability of niches. In the end, what matters in this post-dinosaur epoch is not a single moment of triumph, but the slow choreography of countless small wins. It is a landscape of experiment and error, where life, in many iterations, refused the finality of extinction and instead rewired itself. The scene closes not with a climactic revelation, but with a promise. Within these modest beginnings lies the possibility of minds that can reflect on the very process that forged them. That possibility is fragile, contingent, and breathtaking. a reminder that the deep history of Earth is at once indifferent and suffused with the potential for meaning. This is the first act of the mammalian story. From the ash and silence, a whispering multitude began to repopulate the world, each lineage a tentative proposal for what life might become. The curious, cautious, warm-blooded survivors that filled the niches left by giants were not yet thinking in the way humans do. They were, at most, beginning the slow accumulation of sensory, social, and structural advantages that would tens of millions of years hence make thought itself a possibility. The next chapters will trace how those tiny experiments, multiplied and refined across continents and epochs, set the stage for the emergence of minds capable of asking the very questions with which this narrative began. What happens when the small, furtive creatures that survived apocalypse discover that the world no longer remembers how to be dangerous in the old ways? What does the planet feel like when absence becomes an invitation? When emptiness reads like a map of possibilities? The age of mammals begins with that question folded into every dawn, a question not of heroics but of accumulation, of dozens of tiny improvisations adding up to new architectures of life. The epoch from roughly 66 to 10 million years ago is a long, patient conversion of marginalia into dominance. It reads like a slow editing process by selection, line after line of life, erased, rewritten, and revised until entire body plans and behaviors emerge where none had stood before. From the small, nocturnal survivors there rose lineages that would command the plains, reshape forests, and in some corners of the world take the first small steps toward minds that could reflect on themselves. The narrative here is not a single arc, but a braided series of experiments, giant herbivores evolving from modest forebears, predators recalibrating speed and guile, primates unfolding in the shaded understory. In the cooler, greener world that followed the immediate aftermath of the impact, plants rebounded with breathtaking vigor. Flowering plants expanded their dominion, grasslands began to wink into being in pockets, and forests developed new canopies. Vegetation did not simply regrow, it reorganized, offering new niches on which mammals could fasten themselves. Where dense forests remained, the vertical dimension became a new frontier. Where woodlands opened into meadows, the horizontal space favored long strides and sustained motion. Different solutions proliferated. One of the most conspicuous transformations was the emergence of large-bodied herbivores, beasts whose scale could rival and in some ways surpass anything in earlier eras. These were not instantaneous appearances, but rather long accumulations of selection on body size, dental architecture, and digestive specialization. In the cool wetlands and wooded savannas, some lineages trended toward bulk as a defense and as a means of exploiting abundant but low-quality plant matter. Larger gut chambers, complex dentition for grinding cellulose, and the metabolic rhythms to support immense bodies all evolved as responses to a world where plant biomass could sustain them. Among these were the ancestors of proboscideans, the distant forebears of elephants. They did not arrive fully formed with trunks and towering bodies. Instead, their evolution is a study in incremental retooling. Early proboscideans began shifting toward heavier, more pillar-like limbs to support greater mass. Facial anatomy gradually elongated, and powerful lips grew more dexterous over millions of years. Muscular elongation of the skull and lip region would culminate in the versatile trunk, a multi-purpose organ for breathing, manipulating food, touching, and social signaling. The trunk itself is a remarkable evolutionary solution. It substitutes reach and fine manipulation for the loss of a hand, and it becomes a locus for social interaction. But in the early stages, These animals were large browsers and mixed feeders, moving in groups that benefited from collective vigilance and social cohesion. Alongside proboscideans, other lineages experimented with mass. Rhinocerotoids and brontothers, huge, horned or hornless browsers, filled niches that demanded bulk. Some carried heavy skull appendages, not merely as weapons, but possibly as displays in mating rituals or as tools for pushing through dense vegetation. Size conferred advantages beyond defense. It allowed access to higher foliage, to more efficient digestion of tough plant material, and to the thermoregulatory benefits of a large thermal mass. But size also imposed constraints: slower reproductive rates, longer developmental times, and higher absolute food requirements. These giants were thus bets against an uncertain future insurance. If environmental stability lasted, liabilities if it shifted suddenly. The grasslands, which later would become emblematic of cursorial evolution, began to sculpt different bodies. Early horses, small multi-toed browsers that would not yet suggest the galloping animals of the Pleistocene, adapted to a mosaic of open and wooded habitats. Their teeth evolved more complex grinding surfaces, their limbs elongated and straightened as selection favored distance and efficiency in locomotion. Each change was a response to a world offering new resources and new dangers. A longer stride decreases the energy cost of traversing large, open areas in search of dispersed forage. A single, weight-bearing toe concentrates force for faster running. Over millions of years, such tweaks compounded into the streamlined, single-toed limbs of later equids. Predators responded to the rise of large herbivores by scaling up their own forms or by specializing in different hunting strategies. Some mammalian carnivores became larger and more robust, capable of taking down substantial prey with coordinated group tactics. Others honed speed, developing elongated limbs and flexible spines for high-speed pursuits. Yet another set adapted to ambush tactics, muscular bursts of power from concealment, the anatomy of patience and sudden violence. Teeth and jaw mechanics diversified accordingly, shearing carnassials in some clades, bone-crushing molars in scavengers, and finely honed incisors in small predators that still stalked brush and burrows. The predator-prey dialogue of this age was not sensational in script. It was a long, iterative choreography of risk and countermeasure. Equally transformative but quieter in public imagination was the evolution of primates in the forests. In the shaded understory, small, grasping mammals found that hands and eyes were complicit in survival. The selective pressures were subtle, navigating three-dimensional spaces, plucking fruits and insects from complex substrates, and maintaining balance on thin branches. Visual acuity became more valuable where depth perception could prevent a fall or a misjudged leap. Forward-facing eyes and stereoscopic vision provided the perceptual tools for precise reach. Grasping digits, nails instead of claws, and flexible shoulder joints allowed animals to move with a combination of caution and confident precision. These early primates were not preoccupied with abstract thought. They were solving immediate problems of locomotion and foraging. But the anatomical investments they made would prove consequential. Above all else, social life intensified in some lineages. Group living is an economy of vigilance and learning. More eyes reduce predation risk, and more individuals increase the opportunity for social learning and the transmission of foraging techniques. In primates, extended parental care and prolonged juvenile periods became common. These longer developmental windows created time for learning complex motor skills and social etiquettes. How to pick the ripest fruit, how to recognize kin, how to interpret subtle gestures. Memory and social cognition scaled up in lockstep with these demands. In other mammalian societies, whether in herds of browsers or packs of predators, social bonds and hierarchies structured interactions, mating, and movement patterns. Social complexity, again, was not equivalent to human-like culture, but it did provide a substrate for behaviors to be passed between individuals, for traditions of foraging routes, alarm calls, and cooperative defense. The sensory world of mammals deepened. Olfactory marking, audible calls pitched across frequencies humans cannot perceive, tactile communication through touches and nudges, all were instruments in the orchestration of life. In proboscideans, for instance, a trunk's tactile sensitivity and an extensive olfactory system created a social lexicon without words. In primates, facial expressions and vocalizations combined with vision to produce a nuanced palette of signals. These were not conscious deliberations, they were evolved responses, nonetheless formative for the social architectures that followed. Climate and geology remained active co-authors in this story. Mountain building, the uplift of ranges, the opening and closing of seaways, and long-term cooling trends all redistributed habitats. The rise of the Himalayas, the shifting of monsoon patterns, the ebb and flow of ice at higher latitudes, these were forces that rewired ecosystems, opened migration corridors, and isolated populations into evolutionary crucibles. Continental fragmentation and periodic connection created opportunities for dispersal and for endemic radiations. Australia, separated for long stretches, allowed marsupials to pursue evolutionary gambits unavailable to placental mammals elsewhere. South America and Africa hosted their own idiosyncratic experiments in form and function. There is a particular kind of suspense in watching these dynamics at deep time scales. Each morphological innovation, an elongated limb, a grinding molar, a more dexterous digit, carries within it the duality of advantage and fragility. An increment that works is preserved. An environment that changes turns advantage into liability. The rise of grasslands, for example, buoyed cursorial mammals but penalized species specialized for closed canopy life. A sudden drought could truncate the success of bulkier herbivores favoring smaller, more generalist feeders. The fossil record is punctuated with such reversals, reminding the observer that evolutionary success is always held at the edge of unpredictable change. In the quieter corners of this age, behaviors of curiosity and exploration percolated. Mammals experimented with diets, omnivory in some lineages, strict herbivory in others, nocturnality retained in many, diurnality resurging in others. Tool use in its primitive forms appears intermittently, stones used to break shells, branches employed to probe for insects, objects selected for processing food. These behaviors were not universal and seldom involved symbolic thought. They were immediate solutions to immediate problems. But they are significant because they demonstrate the plasticity of behavior, the capacity to adjust strategies based on environmental affordances rather than fixed instincts alone. Human-like intentionality was not present. This era does not suggest an inevitable arrow toward human cognition, but it set the scaffolding. Increases in brain size relative to body size in certain lineages, the elaboration of sensory processing, and the social dynamics favoring learning and memory all accumulate. Over millions of years, these changes layered into architectures that could support more flexible, planning-oriented behaviors. The story that leads eventually to hominins is not linear or foreordained. It is the result of contingent accumulations, in particular ecological and geographical contexts. The emotional tenor of the age of mammals, if the epoch could be felt as an emotional landscape, might be described as cautious expansion. There was optimism coded in the willingness of lineages to take risks, explore new diets, exploit open habitats, but also a constant vigilance. Where the dinosaurs' rule had been absolute, the mammals' rule was iterative and prudent. Life experimented with bolder morphologies and at the same time maintained the conservative strategies that had ensured survival in the early post-impact years. Parental investment, nocturnality, where useful, burrowing, and sociality where vulnerability demanded. To stand imaginatively in a clearing 40 million years ago is to feel small in the presence of processes that outlast lifetimes. To watch a herd of large-bodied herbivores trundle across a sunrise, slow and ponderous, to sense the quiet calculation of a predator studying the wind, to note the deft, almost meditative movements of primates in the canopy plucking fruit with fingers that will one day do different kinds of work. These moments are not cinematic in the human sense. They are episodes in a long experiment in resilience and opportunity. The spectacle is not in grandeur alone, but in the stubborn accumulation of small solutions. And there is always the undercurrent of contingency, a shift in climate, the arrival of a new competitor, a disease. Any of these could have truncated particular trajectories. The magnitude of chance is humbling. Yet despite the precariousness, the age of mammals is a testament to life's potential to reimagine itself. It shows how, given time and a mutable planet, organisms will find ways to occupy vacuums of opportunity. In the end, this era does not resolve into a single moral. It is a meditation on process. The rise of primitive elephants, the gargantuan browsers, the first true horses trotting toward the horizon, and the cautious, clingy primates in the treetops, all are variations on a theme. Life filling space with forms and behaviors that, while imperfect and temporary, are profound in aggregate. The age of mammals is less a climax than a foundation. It is the slow, vast work by which bodies grew, brains elaborated, and social worlds thickened. In those dense forests, on those open plains, the ingredients for later cognitive complexity were being assembled, one cautious innovation at a time, under a sky that remembered giants and a ground that was freshly hospitable to new kinds of dominion. What does it mean for a world to learn a new language of touch? What does it mean when hands, for the first time, begin to see as much as the eyes do? In the interval between roughly 55 and 7 million years ago, the planet staged a quiet experiment. Small, warm-blooded mammals began to remodel their bodies and minds to meet the geometry of life in the trees. The change was not a single invention, but a slow accretion of coordinated skills, precision grips, stereoscopic sight, nimble limbs, and social habits that together opened a kind of potential that the Earth had not yet hosted. In the fossil record, this era registers as a diffuse blooming. Early primates and primate-like mammals, plesiadapiforms at the opening edge, followed by the more recognizably primate groups of the Eocene, such as adapiforms and omomyids, appear in leaf litter and on subtle bone surfaces as hints of a different life strategy. Their anatomy tells the story, hands and feet that could manipulate rather than merely grip, forward-facing eyes that overlapped their visual fields, skulls with expanding cortices. But reading bones is like reading a single photograph of a long conversation. To understand what was changing, one must listen to the implied choreography. An animal reaches, another tests balance. Juveniles practice, leaps in the shade, and across generations neural circuits rewire themselves to prioritize coordination. The selective pressures that favored these changes were deceptively simple and spatially specific. Forests offered a three-dimensional world of food and refuge, fruit hung from twigs that bent, Insects hid beneath bark, and safe pathways required a continuous negotiation of thin supports. In that context, sensory coordination mattered in new ways. Vision could no longer be content with detecting motion on a flat plane. Depth perception became a survival tool. Misjudge a branch and a fall could be fatal. Hands needed to do more than hook under a limb. They needed to size a fruit, adjust grip strength, pluck an insect from a crevice. These demands selected for anatomy and neural wiring that linked eyes to hands and hands to the brain in tighter, faster loops. Anatomically, the changes are telling. The digits of early primates show evidence of increased flexibility. Longer fingers with more mobile joints, tactile pads rich in nerve endings, and in many lineages, a shift from sharp, grasping claws to flattened nails. Nails are not a mere cosmetic substitution. They are part of a reconfiguration of how digits are used. A claw functions as a tool for hooking and anchoring, but a nail permits a pad of skin to press against surfaces, allowing fine pressure discrimination and friction management. That tactile sensitivity, combined with a sensitive tip of the finger, enables the precision grit, a controlled opposition of thumb to finger, that makes possible delicate manipulations. The opposable thumb, primitive in the earliest forms and more refined in later ones, did not appear overnight. It emerged as a graded increase in thumb mobility, a change in bone proportions, and a reorganization of the musculature that controls it. Each anatomical tweak multiplied the behavioral repertoire. Vision followed a parallel trajectory. Eyes moved toward a front-facing orientation in many primate lineages, increasing the overlap of the visual fields from each eye and producing stereopsis, true binocular depth perception. The parts of the brain that processed visual information enlarged, not simply in overall size but in specialization. Motion detection, color discrimination, and the fine passing of surface textures gained more neural real estate. Why color? In a world where ripe fruits and young leaves can differ subtly from their unripe counterparts, color vision is more than luxury. It becomes an information channel about food quality and safety. The Eocene, for much of its span, was warm and lush, an orchestra of verdant resources that selected strongly for organisms that could discriminate and select. Coordination skills, the actual coupling of seeing and grasping, were the behavioral manifestation of these anatomical investments. The first primates to truly exploit arboreal niches did so by learning to coordinate gaze, posture, and manual action. Reaching was not an ungainly lunge, but an anticipatory movement, the eyes locked on a target, the body balanced on a weighted tail or a stabilizing hind limb, and the hand adjusted grip force in microseconds. These were sensory motor feats that required not just muscle, but a nervous system capable of predicting outcomes and correcting errors, an early form of forward modeling. The neural capacity to integrate tactile feedback with visual input and to adjust ongoing motor programs is the kind of computation that prefigures more abstract forms of problem solving. Learning, especially early life learning, became central. Parental investment in many primate lineages increased relative to smaller, more precocial mammals. Extended juvenile periods provided the temporal canvas for mastering delicate locomotor skills. How to judge the flex of a twig, how to time a leap, how to pluck a fruit without sending it tumbling away. Play, often dismissed as frivolous, was in fact an apprenticeship in coordination. Juveniles tested their grip on different substrates, chased one another along lianas, and experimented with manipulating objects. Each error taught balance and timing. Each success reinforced neural pathways that would be used for foraging and social interaction. The social dimension mattered because the forest is, for many species, a social place. Group living amplifies opportunities for learning. Observational learning allows young animals to see which branches are safe to use, which food items are preferred, and which gestures signal warning. The social consequences of these developments were profound but subtle. Grooming behavior, which in many primate lineages becomes elaborate, acts both as hygiene and as social currency. Bonds are forged by the exchange of touch, vocalizations, and facial expressions, supported by increasing sophistication in the visual system, combine with tactile signals to create a multimodal social lexicon. The neural substrates for recognizing individuals, for remembering past interactions, and for responding to social cues expanded. These were not words or symbolic language, they were distributed, embodied systems of information exchange that allowed groups to coordinate movement, to warn of predators, and to maintain alliances. Social memory, who groomed whom, who had access to which resources, began to matter for reproductive success. The cognitive consequence was selection for better memory, discrimination, and social inference. Ecology and climate steered the course of primate evolution in ways that were both enabling and constraining. The early Eocene climatic optimum, a period of pronounced warmth, opened northern forests and allowed primates and primate-like mammals to disperse into areas that are today temperate. Fossils from Europe and North America testify to a time when subtropical forests stretched into high latitudes. During these warm pulses, primates diversified, exploiting a range of arboreal microhabitats. But climate did not remain constant. Cooling trends in the later Eocene and into the Oligocene retracted forests toward the equator, fragmenting habitats and isolating populations. Isolation is evolution's laboratory. It generates divergence. Some lineages contracted and specialized, others migrated or adapted to the changing mosaic of woodlands and open areas. These vicissitudes produced the early splits between lineages that would become lemur-alike, strepsirrhines, and the haplorhines that would later give rise to monkeys and apes. Geography mattered as much as climate. Continental currents, land bridges rising during low sea levels, island chains forming and vanishing provided opportunities for colonization. Madagascar, isolated early and then persistently cut off, became a crucible for lemuriform radiation. The route was improbable. Rafts of vegetation, chance storms, but over millions of years loners that reached the island found a world free of many mainland competitors and predators and radiated into diverse forms. Likewise, primates reached South America in a similarly contingent way, crossing ancient seaways to exploit new ecological space. The biogeographical patchwork allowed parallel experiments in what arboreal mammals could become. Diet, too, shaped anatomy and behavior. Frugivory and insectivory imposed different demands. Fruit gleaning selects for precise hand control and color vision, while insect hunting rewards rapid, targeted strikes and acute hearing. Several primate lineages showed mixed diets, and omnivory fosters behavioral flexibility, an important trait in changing environments. Dental morphology reflects these choices. Cusps for crushing insects, flattened molars for grinding fruit, pulp, and leaves. Changes in feeding behavior sometimes led to unexpected innovations. The use of simple objects to access food, sticking twigs into crevices, peeling bark to reveal larvae, surfaced in marginal and opportunistic contexts. These proto-tool behaviors are not the same as deliberate tool manufacture, but they indicate a capacity to exploit external objects as extensions of the body's action repertoire. Such behaviors require an anticipatory cognition, the recognition that an object can mediate an effect on another object or a food source. Throughout this span of tens of millions of years, the archaeological silence is notable. Bones and teeth preserve, but behaviors often do not. yet patterns emerge. Increasing encephalization. The relative growth of brain size appears in several primate clades. Not all brain expansion denotes advanced cognition. Some is tied to sensory processing demands. Still, the trend toward more cortical tissue, particularly in regions associated with vision, tactile processing, and social cognition, laid the neurobiological groundwork for flexible behavior. Neural plasticity, the capacity for the brain to reorganize in response to experience, was itself being selected for when juvenile learning and social complexity provided survival advantages. And yet, as with everything in deep time, contingency rules. Small environmental shifts could have closed off the very pathways that led to later primate success. A prolonged cooling that eliminated arboreal corridors, a surge of competitors, a disease that disproportionately impacted species with long juvenile dependence. Any of these could have reshaped the possible. The fossil record hints at dead ends, lineages that briefly experimented with grasping hands or larger brains only to vanish. Evolution is a serried series of bets, most of them lost. The ones that persist do so not because they were destined, but because they fit a narrow corridor of conditions, timing, and luck. The emotional texture of this epoch, were it to be described in human terms without personifying individuals, is a hybrid of cautious curiosity and patient learning. There is a sense of deliberation woven into the movement of hands through foliage, a persistently tentative optimism in the juveniles practicing leaps and grips. The world provided possibilities, fruiting trees, complex substrates, social living, and those possibilities invited new kinds of attention. Attention, in turn, is a precursor to thought, to focus on a specific object, to hold it in mind across a delay, to modify one's action on the basis of observed consequences. These are the scaffolds for more abstract cognition. By 7 million years ago, the primate experiment had accumulated significant capacities. Manual dexterity that could differentiate power and precision, vision that could parse depth and color, social systems that favored learning and memory, and brains increasingly wired to integrate these inputs into coordinated action. None of this guaranteed the later emergence of hominins or human-level cognition. What it did guarantee, in the most literal sense, was potential, a set of morphological and neural tools that made certain futures possible. The story of primates in this deep interval is not one of predestination, but of preparedness. Evolution fashioned versatile instruments. Future chapters in Earth's history would determine how those instruments were put to use. Viewed from the distance of deep time, the rise of primates is less about achievement than about the patient articulation of capability. Hands that could feel and eyes that could judge depth created a feedback loop between perception and manipulation. That loop amplified opportunities for learning and social complexity, which in turn favored neural investments that improved coordination. These entwined changes did not proclaim an inevitable march toward intelligence, they merely opened doors that had previously been closed. For a planet that had once been dominated by forms of sheer scale, this was a new direction. Not gigantism but finesse, not force but finesse, coordinated by attention. This was the slow, intricate work of becoming, a world teaching itself through bodies that learn to touch, to see, and to remember. The first primates with potential did not change the planet with thunder or flame. They altered it quietly by making room for subtlety, by privileging the interplay of hand and eye, of social living and learning. In that unassuming reconfiguration lay the possibility of minds that, much later, would look back and ask the very questions with which this narrative began. What happens when the body itself rearranges its priorities, when the spine decides that the ground beneath will be walked upon and the hands are relieved of the duty to propel. What small rebalancing of limbs and instincts can set into motion centuries of social experiment? These are the questions that haunt the interval between roughly 7 and 4 million years ago. A hinge in the story of life in which form and fellowship quietly conspired to open new possibilities. In that long, grainy interval, the tree of life near the human limb sent a tentative branch outward. The lineage that would eventually become hominins and the lineage that would become modern chimpanzees pulled apart, not in a single dramatic tear, but in a long negotiation with climate, terrain, and habit. Fossils like Sahelanthropus and Orrorin register that negotiation as a set of anatomical propositions. A foramen magnum shifted forward under a skull, a femur shaped for weight, bearing, teeth that begin to say different things about diet and social competition. These are not destiny's pronouncements. They are the faint signatures of new problems being solved, of bodies experimenting with new solutions. The most consequential experiment of this era was bipedality, or more precisely, the gradual reorientation of how some hominins moved through their world. The first tentative uprights were not triumphant postures, they were compromises. Upright walking appears as a mosaic of features. Changes in the pelvis that shorten and widen the basin, lumbar lordosis that curves the lower spine, a valgus angle at the knee that positions feet under the center of mass, and a foot with a more adducted big toe capable of transferring force under load. The result was neither elegant nor efficient at first. It was awkward, breathy, and slow. But it was profoundly enabling. Walking on 2 feet altered the calculus of the body. Hands, no longer enslaved to balance and locomotion for extended periods, began to be used in novel ways. They clasped and carried, food items ferried from one place to another, infants cradled against the chest as mothers moved between feeding trees and safer clearings, and later stones and sticks appropriated as extensions of the body. Freed hands created new behavioral microeconomies. The ability to gather and move resources collectively, the capacity to transport useful objects across spaces, and the emergence of gestures that could choreograph social life. The biomechanical shift from quadruped to biped had simple mechanics and complex downstream consequences, an architectural change that reconfigured social possibilities. The landscapes these early hominins navigated were also being recast. The East African Rift, a tectonic bruise that would reshape drainage patterns and microclimates, was creating a patchwork of gallery forests, scrub, and open grasslands. Winters lengthened in some seasons, dry spells arrived with greater regularity. Resources became spatially and temporally patchy. In such a world, mobility mattered. Long, efficient walks between clumps of fruiting trees or between carcass and shelter were adaptive. Bipedality, even an imperfect version of it, reduced the energetic cost of traveling compared to clambering across the same distances on all fours. It also exposed hominins to a different horizon, one that favored scanning for predators and foraging opportunities over longer sightlines. Standing taller, literally and figuratively, changed what could be seen and what could be carried. There was an emotional geometry to this bodily reorientation. From the perspective of an imagined hominin mind, reconstructed cautiously as an inference from bone and context, there would have been states of heightened attention and a new kind of practical anxiety. Mobility introduces trade-offs, increased vulnerability in open spaces, but also the chance to exploit resources too diffuse for less mobile foragers. Where infants were involved, there was intensified need for vigilance, for the sharing of caregiving duties, and for coordination among group members. The pressures of provisioning and protection seeded social solutions that would ripple outward through millennia. Group life deepened during this period. Foraging in environments where food was dispersed tends to favor cooperative strategies, shared vigilance, coordinated movement, and selective tolerance around valuable resources. Group size likely increased in some populations because safety in numbers reduced predation risk, and because cooperative behaviors allowed more efficient exploitation of patchy food. Within these groups, social pressure competition for mates, the need to maintain alliances, and the benefits of reciprocal aid began to sharpen. Reputation became a nascent currency. An individual who shared food or who babysat another's infant during a raid by predators increased its social standing in subtle ways that affected mating opportunities and survival odds. These were not moral choices in the human sense. They were the evolutionary arithmetic of costs and benefits encoded in repeated interactions. The fossil and isotopic records hint at dietary shifts that accompanied these social permutations. Teeth change slowly, but they record the story of food. Larger molars with thicker enamel suggest diets including harder or more abrasive items. Reduced canine dimorphism can suggest altered mating systems, and lower male-to-male aggression. Microwear patterns on enamel whisper of seeds, tubers, and occasional meat. Meat, once acquired via scavenging rather than hunting, became a concentrated resource around which social habits could form. Meat sharing is expensive but high return. Cooked a millennium later, it becomes culture. In these early assemblages, shared meat could forge alliances, create obligations, and incentivize collaboration in carcass retrieval and defense. Hands, freed from locomotion, developed another repertoire: manipulation. The thumb became more opposable. Precision grips started to appear as a probabilistic feature of some hands. These grips did not first appear for making stone tools, at least not immediately visible as such in the archaeological record, but for holding and manipulating objects, pulling leaves, scraping hides, supporting an infant's head, or levering open a nut. Objects in the environment began to play the role of prosthetic limbs, allowing simple causal chains to be extended beyond the body. That cognitive extension, recognizing that one's action upon an object can affect another object or resource, nurtures an anticipatory mind. Anticipation is the seedbed of planning, and planning, in turn, is essential for cooperative strategies that depend on timing and trust. Increasingly elaborate parental investment was another hallmark. Bipedalism and the evolution of a narrower birth canal meant that infants were, relative to some other primates, more altricial, more reliant on caregivers for longer durations. Extended childhoods provided both vulnerability and opportunity. Developmental plasticity became a laboratory for learning complex social and motor skills. Juveniles practiced walking upright, refining balance, and experimenting with manipulation. Play, a behavior often dismissed as frivolous, functioned as apprenticeship, chasing, wrestling, handling objects, all rehearsals for adult roles. These prolonged infancy and juvenile phases increased the value of social bonds. Kin networks and cooperative caregiving reduced the mortality risk of dependent young, and in doing so, they favored social scaffolds that could transmit learned behaviors across generations. Communication shifted in subtle ways that left poor traces in stone but clear echoes in social anatomy. Vocal apparatuses began to change. Facial musculature and the expanding brain's auditory centers allowed for more nuanced calls, and gestures acquired more intentionality. Nonverbal signals, arm movements, carrying postures, touches served as low-bandwidth languages for coordinating movement and caring for infants. The freeing of hands allowed visual signals to complement vocal ones. Because these communicative acts are ephemeral, the fossil record is silent, but behavioral ecology is not. Modern primate analogues show how gestures and simple calls can coordinate group travel, indicate food sources, and initiate grooming. It is reasonable to infer that proto-hominin groups used a similar multimodal communication to manage their increasingly complex social worlds. This period was also one of contradiction. Mobility encouraged dispersion, but sociality encouraged aggregation. Hominins faced the constant question of when to split and when to stay together. The environment's patchiness made fission-fusion dynamics advantageous. Groups that could split into smaller foraging bands and recombine when resources were rich gained flexibility. Such dynamics require social memory and individual recognition. If an individual is to join another band after a week apart, it must recognize faces, remember favor exchanges, and evaluate trustworthiness. These cognitive demands select for improved memory, discrimination, and the rudiments of reputation tracking. Social life was slowly, almost imperceptibly, creating the cognitive architecture of reciprocity and punishing freeloaders. The climatic backdrop tightened this selection. Cooling trends toward the end of the Miocene and the opening of more savanna-like habitats placed a premium on flexibility. Some lineages retreated into woodlands, preserving arboreal adaptations. Others pushed into mixed habitats where a dual skill set, competent at trees and on the ground, was advantageous. This mosaic setting amplified the value of behavioral versatility. Individuals that could walk between feeding sites, carry useful items, exploit underground storage organs, and cooperate with peers to access risky but rich resources had an edge. Yet contingency loomed everywhere. The emergence of bipedality and greater social complexity was not inevitable. Small climatic shifts, new predators, disease, or simply the failure of a local group to cohere could have erased these nascent possibilities. The fossil record shows dead-end experiments, lineages that flirted with habit shifts only to disappear. Evolution proceeds by 100 such tentative acts, most of which fail. The hominin path was narrow and beset with hazard. There is drama in the mundane moments. A mother balancing an infant on her hip as she walks between trees. A young individual testing the tensile limit of a branch with a tentative foot. A small cluster of hominins dividing the spoils of a scavenged carcass. Subtle barters of meat or shelter for grooming and alliance. These are not heroic tableaux. They are the everyday labor of survival and sociality. Yet it is precisely in this repetition that the scaffolding of later human social complexity was erected. Small acts accumulate into cultural habits, the norm of sharing, the expectation of reciprocal care, the social memory of favors and debts. By 4 million years ago, what had been a tentative bipedal repertoire had, in some lineages, become habitual. Australopithecus, emblematic of this transition, walked with a pelvic and lower limb anatomy adapted for upright posture, even as some arboreal competencies persisted. Their hands could do more than grip, their mouths and teeth told of varied diets. Social life had become complex, not in the sense of narrative plots or conscious foresight, but in the sense of repeated, interdependent interactions that selected for memory, recognition, and tolerance. These hominins were not thinkers in the human way, but they were agents of social practice. They created expectations and rules, implicit, enforced by action rather than by law, that would persist and be inherited in behavior, if not in genes. If one must name the emotional tenor of this epoch, it would be an anxious curiosity. The bodies that walked upright were tentative innovators, balancing the need to move with the need to nurture. Their social worlds were laboratories of cooperation, conditional on trust and memory. Hands freed from locomotion did not immediately craft elaborate tools, but they created the possibility of extended causality. the idea that an object could bridge intention and consequence. Bipedality did not make minds, it made certain ways of living possible. Those ways, mobility, carrying, cooperative provisioning, prolonged juvenile dependence, and more complex social binding, were the foundation upon which later social behaviors, symbolic communication, and tool-based cultures could be constructed. Viewed from the abyssal perspective of deep time, the significance of these millions of years is not an act of grandeur, but an accretion of small, stubborn changes. A forward-shifted foramen magnum, a more curved lower spine, an opposable thumb that gained a degree of precision. Each is a brushstroke in a long, patient painting. The painting depicts not a single hero but a social experiment, organisms learning, by trial and error, that cooperation could be a strategy for survival, that carrying could be an investment, that infants could be a nexus for social bonds. The story that unfolds between 7 and 4 million years ago is not about inevitability. It is about preparation. It is the slow assembling of anatomical tools and social practices that would, much later and in particular places, be recombined into the capacities that ask the questions with which this narrative began. What does a thinking thing feel like the first time it takes hold of the world and reshapes it? What is the interior weather of a mind when it discovers that stones can be made to bite, that scraps of flesh and the hidden white of tubers can be altered not merely by teeth but by a crafted edge? These are not metaphors for an instant epiphany. They are questions about slow, repeated acts, about a species learning through touch and accident that the environment is not only something to be endured but something to be managed. Between roughly 3.3 and 2 million years ago, the world of hominins changed in ways that are tactile as much as cognitive. The archaeological signature is straightforward. Small, sharp flakes struck from cobbles and cores, Oldowan tools, scattered across river terraces and lake margins. The signature's simplicity is deceptive. Each flake implies a chain of perception, decision, and action. The selection of a suitable stone, the anticipation of impact, the precise angle and force of a strike, and then the use of the resulting edge to transform food into fuel for a brain. To see the old Darwin across time is to see the first conversations between hand, eye, and world. Imagine a riverbank at dawn, not as an illustration, but as a laboratory of repeated failures and occasional successes. Stones of different shapes lie like potential sentences waiting to be formed. A hominin, no single hero, but one among many, bends, selects a cobble that rings with a particular tone when tapped, and positions it against another rock. The first strikes are exploratory, clumsy, imprecise, flakes fly in unpredictable arcs, and the hand smells of river silt. There is a learning curve etched into the bones. Repeated percussion creates calluses. Wrists become practiced at absorbing shock. Eyes learn the minute variations in grain that will yield a clean flake. The sound of stone on stone is a new percussion in the landscape, a small but persistent punctuation to the day. The immediate functional payoff is undeniable. An edge, even a crude one, sharpens possibilities. A cut separates hide from flesh more cleanly than a tooth, easing processing and increasing caloric yield. A flake preys at a tuber's skin, making access to starchy underground reserves possible in seasons when fruit is scarce. Carrying becomes an arithmetic of risk and reward. The hand that can hold a stone is also the hand that can hold a morsel, a root, an infant. Bipedality, which had already loosened hands from the primacy of locomotion, now becomes a practical advantage. Food can be transported across distances, taken back to a cluster of conspecifics, and shared. Carrying is, in this narrow sense, an act of planning, a delay of immediate consumption for the sake of distribution or storage. But these are more than logistical notes. In the repeated acts of striking, cutting, and carrying, an emergent mental architecture is being rehearsed. Toolmaking requires a grasp, not just physical, but temporal, of sequences. Strike here. Remove that flake, use the edge in this orientation. The mind engaged in napping must anticipate outcomes a few moments ahead, predict the way a massive rock will split, and correct mid-motion when the fracture proceeds unexpectedly. Those anticipatory habits are the precursors of planning, the capacity to hold, temporarily, a chain of actions and to act so that a future state will be achieved. Each successful flake is a small proof that the world will behave in predictable ways if acted upon thoughtfully. The consequences ripple socially as much as individually. A sharp flake opening a carcass in one place creates a social artifact. The meat becomes transportable, shareable, and contestable. Where before meat might have been eaten on the spot by those present, now portions could be taken to a home base reserved for others or used as leverage in social negotiations. The emergence of food transport implies choices: whom to feed, when to share, which individuals merit tolerance. Acts of sharing begin to generate reputational dynamics. Reciprocity and selective generosity become adaptive pathways for social cohesion. Cooperation around food is pragmatic at its root, but repeated cooperation knits trust into groups, and trust is a cognitive commodity that enables more complex social strategies. There is also the quiet revolution of learning by example. Toolmaking and butchery are learnable skills. Observation is an educational technology. Juveniles who watch repeated demonstrations internalize sequences of action. How to grip a core, how to position a flake, how to angle a cut to avoid scraping away meat. The transmission is not linguistic in the modern sense, it is embodied. Bodies choreograph hands, eyes follow, and imitation cements neural patterns. Mistakes are visible and instructive. A fractured core that produces waste is, simultaneously, a lesson about angle and force. Over generations, small improvements accumulate: more consistent flakes, more efficient strikes, subtle modifications that increase the lifetime usefulness of a core. The cognitive shifts, while modest in any single instance, begin to take shape as a network of capacities. Working a stone requires fine motor control and tactile sensitivity, elements that are reflected in changes to hand anatomy and neural investment. Grasping precision improves. Opposable thumbs gain subtle degrees of mobility and strength. Visual systems tune more finely to the movements of others and to the microtextures of rock faces. Memory strengthens. Not only episodic recollections of where nice cobbles were found, but procedural memory, the remembered sequence of actions that will result in a usable flake. The mind that can remember a hitting angle and then reproduce it is practicing the cognitive scaffolding of intentionality. Carrying food back to a social nucleus multiplies the cognitive complexity. Transport creates temporal buffers between acquisition and consumption. Those buffers open opportunities for planning. Food can be stored where it will be safe, caches can be revisited, prime locations can be guarded. Even the simple act of holding an edible object while navigating terrain demands decision-making: where to place it, how to balance it with other tasks, whether to eat now or preserve the resource. The very concept of delay, the capacity to prefer more later over less now, becomes a seed of foresight. Across many small choices, hominins practice deferring immediate gratification, a habit with profound downstream implications for cooperation, social politics, and the capacity to assemble multi-step technologies. The material environment underwrites and is altered by these behaviors. River terraces and lake shores become concentrations of repeated activities. Stones bear scars from numerous strikes. Bones accumulate at butchery sites. Such places become loci of cultural continuity, return sites where techniques are refined and traditions can be rehearsed across generations. The landscape, in turn, shapes cognition. When certain objects are reliably available, quality cobbles, nutritious tubers, investment in techniques that exploit those resources becomes valuable. Selection, both biological and cultural, nudges behavior toward economies of efficiency. Yet this economic transformation is porous to chance. Not all old Owen assemblages show the same patterns. Some localities preserve long sequences of flake refinement, others only disordered scatters. The presence or absence of suitable raw materials, the unpredictability of scavenging opportunities, and the presence of competitors all determine whether tool use will become habitual within a population. Evolution proceeds not by inevitability, but by 100 small contingencies. Tool-making persisted where ecological affordances and social structures aligned. The sensory world of these hominins also shifts. The smell of blood and exposed marrow carries new significance, not only as reward, but as a cue that promises social interaction and the renegotiation of relationships. The damp, sweet scent of the tuber unearthed in the morning becomes an indexical signal. It tells of seasonal abundance, of nutritional supplements during lean times. Touch, already salient in arboreal ancestors, intensifies in the context of tool-making. The sensation of stone grit under the pads of fingers, the torque of a wrist as the hammerstone is swung, the slight give when a flake detaches. These sensory registers become part of the learning environment. They modulate attention and memory. A certain resonance in a cobble when tapped may indicate suitability. A particular resistance when striking may suggest a poor angle. Such embodied cues accelerate skill acquisition and bias selective retention of techniques. At the neural level, the repeated coupling of vision, touch, and motor planning encourages plasticity. The brain that must coordinate a precise strike benefits from circuits that integrate sensory input quickly and map it onto motor outputs. Repeatedly performed actions consolidate into habits, freeing conscious attention for higher-order planning. In this way, the cognitive load of napping decreases with practice, and energy is freed to consider longer sequences: where to carry a carcass, how to divide food, when to guard a cache. The capacity to offload repetitive tasks into automated routines is an enabling mechanism for planning, social negotiation, and the mental manipulation of absent objects. Language, in any robust symbolic sense, is not yet part of this story. But pre-linguistic communication, gesture, vocalization, directed gaze marches in step with material practice. A lifted arm may indicate a desired direction, a particular call may assemble group members to a carcass, shared attention, and ability to coordinate focus on a single object becomes an important social glue. The combination of shared material practice and shared attention creates a cultural ecosystem where meanings can stabilize. A name for a favored site, a set of gestures to recruit help, the silent convention that certain individuals will defend a cache. These are not words, they are proto-conventions. They scaffold future symbolic systems by establishing communal reference and predictable social norms. There is drama in the ordinary repetition of these acts, not the drama of heroic leaps, but the suspense of trial and error. A young hominin attempts to remove a flake and fails. Another watches, adjusts the angle, and succeeds. Over seasons, the group's competence increases, not because a single genius taught everyone at once, but because social learning amplifies small improvements. Each success raises the stakes. An edge allows access to richer calories, which supports greater energy expenditures, which in turn may support larger brains in certain lineages. The feedback loops are slow but potent. Importantly, these changes are not uniform across space. Some populations retained generalized diets and minimal toolkits. Others leaned heavily on stone technology and the exploitation of carcasses and underground storage organs. Geography, resource distribution, and chance migrations determined whether the making and carrying of food would crystallize into persistent traditions. The fossil and archaeological records are snapshots, thin glimpses into a mosaic of experiments, many of which left no descendants. By 2 million years ago, Homo habilis and its kin had etched a new kind of habit into Earth's deep narrative. The act of making an edge and using it to access high-quality food was a cognitive watershed, not because it produced minds identical to ours, but because it instantiated a network of behaviors that fostered memory, planning, social negotiation, and technical transmission. The first tools were simple. Their implications were anything but. The workshop was not a temple, but a place of practice, where hand and world conspired to teach a species that the environment could be altered by intention, and that such alteration could be transmitted socially. If the earlier epochs had been about bodies learning new postures and sensory registers, this span is about minds learning that the future can be manipulated by present acts. The stone flake and the carried tuber are small tokens of a larger truth. Cognition can extend into material culture. Tools externalize intention, carrying distributes it across time and people. The first sparks of thought, then, were not fireworks, but steady embers, small, repeatable acts that began to cultivate an awareness of cause and consequence, of delayed return, and of shared attention. In the hands that struck and in the mouths that shared, a nascent habit of mind was being coaxed into being. The habit of treating the world as a place where small, deliberate acts build futures. What does it mean, on the scale of deep time, for a species to learn how to hold a small sun in its hands? What changes when a fragile animal no longer waits for lightning to strike, but instead keeps embers alive from one season to the next? This is the quiet, consequential question at the heart of the era when Homo erectus mastered fire roughly between 5 million and 500,000 years ago. And the answer is a chain of cause and effect that reaches into physiology, social life, technology, and the very rhythms of daily existence. The first image that must be held is not a single dramatic blaze, but a series of small, repeated acts. A glowing coal pressed into an animal hide and carried like a precious eye, a cache of dry grass protected against wind and damp, a circle of stones arranged against leeward sides to cradle warmth. Fire did not arrive in a single triumphant moment. It arrived as practice, as the learned habit of capturing natural flames and then, crucially, keeping them. The ability to maintain a slow, controlled burn, hearth-keeping, is an invention of routine and attention. That routine was itself a social technology. It required turn-taking, knowledge transmission, and a reorganization of group priorities around a persistent source of heat and light. Cause, the control and maintenance of fire. Effect, the creation of a material and social focal point, the hearth, that reorganized gatherings, provisioning, and risk management. At the hearth, the immediate transformations were sensory and pragmatic. Light extended the day. Where twilight once drove groups to shelter and silence, small fires permitted activity, work, and social interaction into the hours that once belonged strictly to the dark. Heat rendered marginal landscapes usable. Cold nights and colder seasons became less absolute barriers to movement and habitation. Smell and taste changed. The scent of smoke, the aroma of heated meat and tubers, the transformed tactile qualities of warmed hides. These sensory shifts produced behavioral feedback loops. When food could be cooked, it could be eaten more safely. When nights were less threatening, Groups could linger together. When wood became fuel, certain plants acquired new roles in life economies. Cause: cooking with fire. Effect: increased caloric availability, safer food, and digestive efficiency that altered energy budgets. Cooking is the technical pivot of this epoch. Raw flesh and fibrous plant tissues are metabolically costly to process. Heat breaks down cellulose, denatures proteins, and releases calories more readily. The consequence is not merely fuller bellies. Over generations, a diet that included cooked items changes the selective environment. Fewer calories expended on digestion-free energy for other organs, and although the details are contested, the broad causal chain is persistent in paleobiological thought. More readily available calories support higher activity budgets, greater reproductive investment, and, in some lineages, the expansion of brain tissue. When food is safe to eat, when the threat of parasites and pathogens is reduced by heat, social sharing of prepared food becomes plausible and valuable. Portable, high-quality morsels become resources around which alliances, debts, and reputations can be built. The hearth, therefore, was an engine of social economics. It was not only where food was made, but where food was distributed. Carrying cooked portions back to a group base encouraged the practice of provisioning, taking the effort to secure an edible item and then investing it into social relationships. Sharing is not gratuitous, it is a reciprocal calculus. Individuals who shared reliably could command tolerance, assistance, and mating opportunities. Groups that developed cooperative norms around food, whether implicitly through repeated expectations or explicitly through ritualized acts, gained resilience in stochastic environments. The simple act of handing a warmed root to a nursing mother or a frail elder thus becomes a node in a web of social obligations. Cause: hearths as places for social interaction and shared attention. Effect: enhanced social learning, memory consolidation, and possibly the preconditions for more complex communication. Light at night changed not just behavior, but cognition. Extended wakeful hours spent in the proximity of flames created opportunities for teaching, for detailed observation, for the rehearsal of skills that day only foragers could not practice. Young bodies experimented with fracture techniques on stove flakes, hands learned the micro-timing of a strike, while elders watched and corrected. Gestures and vocalizations could be rehearsed in safety, faces were visible, expressions readable, and eyes could follow another's finger to an object. Shared attention, the capacity to jointly focus on an external event or object, and to use that focus to guide another's behavior, found a stable social stage in and around hearths. Over many nights, these acts of joint attention could strengthen memory circuits and foster conventions about how to conduct social life. This changed the tempo of learning. Skills that required slow, repeated practice, precise napping, butchery sequences, the seasonal mapping of food resources, could be transmitted more reliably when groups had secure places to practice and to observe. The archaeological record begins to show concentrations of repeated activity, burned horizons in caves and open sites, repeated placement of hearthstones, patterns of discarded bones and flake detritus. Those are the fossil signatures of cultural transmission in motion. The new relationship with fire also changed mobility and geography. With heat and the capacity to cook, hominins could occupy colder latitudes and more marginal niches. The expansion of Homo erectus into higher latitudes and diverse climates is partially enabled by controlled fire. Cold tolerance, previously a limiting factor, became negotiable. Shelters could be made more hospitable, nights were survivable in places where nightly lows would otherwise impose high mortality. The ability to control microclimates at the site level enabled longer forays, seasonal aggregations, and ultimately the colonization of a wider range of habitats. Cause: fire enabling habitation of marginal climates. Effect: broader geographic dispersal, population resilience, and increased encounters with new ecological pressures. Fire also altered the interface with predators and competitors. Flames and smoke are deterrents. They create zones that many large carnivores tend to avoid. Even embers and smoky perimeters reduce the likelihood of nocturnal attacks. The protective effect of the hearth reduced very specific environmental risks, which cascaded into other effects. Sleep consolidation during safe nights allowed for longer REM and deep sleep phases, which many neuroscientists argue are important for memory consolidation and learning. Regular, predictable sleep schedules grounded by technology may have incrementally altered cognitive architecture, not by instantaneous rewiring, but through generations of selection on organisms that experienced more consistent restorative sleep. Another technical consequence was the increased utility of materials. Heat transforms materials in predictable ways. Meat softens, skins can be dried and softened for better utility, and organic adhesives may become more workable. There is a cautious possibility that controlled fire allowed hominins to experiment with heat, altered materials in more complex technological chains, not yet metallurgy, not yet ceramics, but incremental manipulations that changed how objects could be made and used. Even the act of baking clay balls into rudimentary hearth lining or hardening wooden implements has precedence in experimentation with heat. These small technical experiments feed back into cognitive habits, planning multi-step processes, controlling timing and temperature, and integrating material properties into problem solving. At the social scale, hearths became symbolic anchor points. The maintenance of fire required norms. Who would carry embers when a group moved? How to fence off the hearth? Who would be allowed near the flames? When to conserve coals for future use? These practices, rules about resource management and access, became cultural conventions. They were not laws in any modern sense, but they were recognizable patterns of behavior that could be taught and enforced. And where patterns stabilize across generations, proto-institutions take shape. Fire also made possible new forms of cooperation that had reproductive implications. Heavy food processing and transport favored coordinated work. Some individuals may have specialized in maintaining hearths, while others scouted for tubers or hunted large game. Division of labor, partial specialization, not along rigid caste lines, but as flexible roles based on skill, age, or sex, becomes a viable strategy when the returns on cooperation are high and when reliability of shared resources is essential for survival. Where such division increased survivorship, it would have become a stable feature of group life. None of these consequences happened without friction. Fire obliged new social prioritizations. It demanded time, attention, and fuel. Fuel gathering could draw people away from other tasks. Embers could be lost to storms. Smoke could repel some animals and attract others. There were risks of burns, of accidental wildfires, and of dependencies that could be lethal if the skill to maintain embers were lost. Consequently, fire-keeping expertise itself would have had value, and the social role of the hearthkeeper. The individual or individuals who could reliably rekindle warmth and light would have been socially significant. The stewardship of flame thus became a form of cultural capital. Looking outward from this period, the longer-term causal chains are profound. Mastery of fire provided an externalized control of environment, the capacity to alter immediate microclimates, to detoxify foods, to concentrate energy into digestible forms, to carve out safe spaces for social learning. Those capacities made possible denser social networks, more reliable transmission of skill, and increased energetic budgets that could be invested in reproduction and, over evolutionary time, in brain tissue. It is not accurate to say that fire alone produced larger brains or language. Rather, fire set in motion a suite of interlocking effects that changed the contours of selection and culture. Equipped with hearths, Homo erectus could accumulate habits and knowledge in ways that were unprecedented. There is also an emotional note to this story. Not of named individuals, but of the collective interiority of a species learning to harness something that until then had been at best an intermittent boon and at worst a danger. The discovery that heat could be tamed must have produced patterns of heightened curiosity and anxious care. Ember carriers learned to be cautious and attentive. Communities cultivated rituals around the keeping of flame. The flicker of a hearth provoked awe in young and old alike, a small, controllable danger that also promised comfort and nourishment. That mix of reverence and pragmatic care is the seed of ritual and the slow beginning of symbolic culture. Finally, the mastery of fire is a lesson in cause and effect writ in ash. A technological habit, learning how to keep a fire burning, altered diets, social norms, mobility, and cognitive practice. Those alterations fed back, reinforcing some behaviors and suppressing others. Over the long sweep from 1 times 5 million to 500,000 years ago, the causes and consequences compounded until fire was no longer just an occasional tool but a sustained axis around which a hominin way of life rotated. The ember carried between hides was more than a glowing coal, it was a portable promise of cooked food, of social bonding, of safety, and of the fundamental human capacity to change the environment in order to change oneself. What does it mean, on the scale of life, to decide that the map drawn by genes and weather is too small? What does it feel like for a species to carry its way of being across oceans of grass and ribboned mountain passes until the world itself seems to expand underfoot? Between roughly 1.8 million and 200,000 years ago, the story of human life becomes a story of movement and invention, departures from origin points in Africa, crossings and crossings again, and a long apprenticeship in how to live where the air bites and the seasons punish the unprepared. This is not a tale of triumphant conquest. It is a meditation on improvisation, on the labor of adapting, and on the narrow corridors through which survival and ingenuity pass. The first migrations were experiments in endurance and patience. Fossil teeth and bones in places like Dmanisi, east of the Black Sea, mark one of the earliest clear exits from Africa, dated to about 8 million years ago. The hominins who made that journey carried with them more than anatomy, they carried habits, sets of skills and expectations about how to find water, how to read spore, how to keep embers alive. Those habits were useful scaffolds, but they were never perfectly tuned to new landscapes. When groups stepped into foreign climates, they discovered differences that could not be reduced to simple comparisons. Rivers flowed differently, grasses had unfamiliar seasonal cycles, predators hunted to new rhythms. Each new place required rethinking the choreography of daily life. Migration was not a single, glorious march, but a palimpsest of small moves. Families split and rejoined, scouts tested corridors, and groups lingered in ecotones, edges between forest and grassland, long enough to learn. The Acheulean hand axe, an elegant biface that became globally recognizable, traveled with many of these people. It is not an emblem of inevitable progress, but a practical technology, symmetric enough to be useful for cutting, scraping, or breaking, portable enough to be carried from river terrace to valley. in a repeated gesture. Select a stone, strike, shape, and trim. The makers externalized ways of seeing rock as resource and of imposing a durable form on the environment. Tools became memory made visible, portable lessons handed between palms. Those palms, freed more reliably by habitual bipedality and refined in their dexterity by repeated manipulative tasks, learned other crafts in response to cold and distance. As population waves pushed northward and eastward, hominins confronted climates their ancestral ranges had never required them to endure. The challenge was not only to keep the body warm, but to reshape daily routines. Cycles of activity had to accommodate longer winters, food scarcity, and nights that closed faster. The archaeological traces of this adaptation are fragmentary and often ambiguous, but a plausible story can be told from the residues, cut marks that suggest hide processing, stone tools found alongside bones of large mammals in cold latitudes, hearths that are repeated in sheltered caves. Hides must have been cleaned, stretched, and draped. Cords spun from plant fibers or sinew might have bound them. Where the archaeological trail is thin, inference must carry weight, but the logic is clear. To remain in icy places without clothing and shelter would have been to court mortality. Shelters were improvised architectures of survival. Natural caves and rock overhangs were invitations and refuges. In more open regions, windbreaks of branches and skins could be erected against lee slopes. These structures were temporary in most places, but repeated occupation of favored sites converted them into loci of memory. Hearthstones blackened by repeated fires, concentrations of stone flakes, and bone scatters that spoke of repeated butchery. A persistent hearth transformed daily life. It became a place for social bonding, for teaching dexterous techniques, and for preserving warmth. The rhythm of returning to the same hearthstones taught the value of maintenance, to keep embers alive during travel, to protect caches, to care for one another in the cold. Those tasks required coordination and created reputational economies. Someone who reliably tended embers or watched infants accrued informal authority because their skill mattered for the group's survival. The movement into new environments favored not just technological improvisation, but behavioral plasticity. Hunting strategies diversified in response to local prey and terrain. In open grasslands, pursuit and endurance were effective. Groups adapted to long, coordinated chases that wore animals out. In woodlands and broken landscapes, ambush and trap tactics were useful, driving herds toward cliffs or into concealed lines of waiting hunters required planning, communication, and timing. Evidence from sites associated with later populations, spears recovered from bogs, patterns of butchery on large mammals suggests that cooperative hunting was not an occasional flash of brilliance, but a practiced repertoire. The social coordination necessary to drive an animal, butcher it, and carry parts back showed that these hominins could synchronize action over time and space, sharing both labor and reward. Food, in its seasonal unpredictability, demanded flexibility. In cooler places, fruit and insect abundance were unreliable. Underground storage organs, tubers, and bulbs became critical. Digging technology, maybe in the form of sharpened sticks or handheld implements, appeared as practical solutions to extract the starchy reserves hidden beneath frost-hardened soils. Shellfish, available along coasts and estuaries, provided reliable calories where terrestrial resources were sparse. Moving along shorelines became an economy in itself. The use of coastal routes for migration has been proposed as a slower, resource-rich pathway that some hominin populations exploited, a lesson in how geography and resource patterns can open or close corridors for expansion. Throughout these millennia, physiological and morphological responses to climate appear as patterns in the fossil record. Robust, stockier builds with shorter limbs and larger nostrils are recurrent adaptations to cold among multiple lineages. They reduce heat loss and reshape respiratory demands. Where warmth favored lighter bodies and long limbs, cold selected for compactness. Those patterns were not inevitable blueprints. They were contingent responses to local selection pressures. They reveal that migration can be a crucible for body morphology as much as it is for culture. Populations that lingered in cold places for many generations accumulated modifications that improved their odds in that environment. Encounters between hominin populations added another dimension to migration. As groups moved out of Africa at different times, they intersected with other hominin lineages, groups that had their own adaptations, histories, and knowledge. The story of Neanderthals in Europe and Western Asia is an instructive example. Adapted to Ice Age environments, their robust bodies and cultural repertoires show specialized solutions to cold. Where early Homo sapiens later encountered Neanderthals, exchanges occurred not only in conflict but also in gene flow and cultural transmission. Genomic studies disclosed traces of interbreeding, and lithic industries suggest borrowing and parallel invention. These interactions complicate any narrative of clean replacement. They are stories of tangled human ecologies in which movement begets contact, and contact begets mixture and innovation. Adaptation was not only to climate, but to new kinds of risk. Pathogens, novel predators, and the vagaries of resource distribution imposed selective pressures that could reshape populations rapidly. The demographic consequences of moving into marginal lands were severe. Small founder groups that colonized new regions were susceptible to loss through disease or failed seasons. Such demographic fragility made migration a gamble. Many forays likely failed, leaving no trace. The presence of widespread archaeological sites alongside long hiatuses in occupation across regions testifies to a history of fits and starts, of gains and reversals. Cultural transmission played an essential role in making adaptations stick. Skills that required long practice, leather working, hafting stone points to shafts, coordinated hunting tactics benefited from social learning. The habitual presence of elders and the repeated return to hearths created the conditions for apprenticeships. Watching, imitating, and practicing under supervision allowed complex skills to persist even as groups fractured and moved. In this sense, migration did not simply redistribute bodies, it redistributed knowledge. A tool-making tradition carried across a mountain range could seed new practices in local groups. A favored cobble source could become the center of a new cultural habit. Cultural memory, encoded in repeated practice and site fidelity, allowed groups to carry flexibility across landscapes. There was an emotional freight to all of this that the bones alone cannot fully reveal, but that can be inferred from the structures of social life. Migration magnified fear and curiosity in equal measure. Leaving known resources for unknown horizons provoked anxiety, the worry for infants, the calculation of risk against reward. At the same time, the scene is shot through with a persistent restlessness, a species-level curiosity that tested boundaries, pushed along coasts, and probed mountain passes. Adaptation required a kind of stoic patience, the willingness to return seasonally, to make small investments in shelter and hearth, to train young ones in the skills necessary for the next winter. Those practices accumulated into an ethic of care for infants and old, maintenance of fire and shelter, and the steady management of shared resources. This ethic was not a moral codex, but a practical network of expectations whose stability improved survival odds. Climate oscillations provided an ever-present drumbeat. Glacial advances and retreats shifted ranges, opened and closed land bridges and remade corridors for movement. Sea level changes exposed new coastlines at times and submerged them at others, altering migratory options. For example, periodic lowering of sea levels created windows for crossing between islands and continents, the reverse trapped populations, isolating them until subsequent sea level changes allowed new contact. These geophysical rhythms imposed tempo on migration, windows when expansion was feasible, and long stretches when isolation reigned. The tempo of technological innovation also responded to migration. In higher latitudes and more seasonal zones, hafting, a technique of attaching stone points to wood shafts, emerged with significant benefits for hunting efficiency. Composite technologies implied cognitive investments in planning and manufacturing, shaping a pointed tip, preparing a shaft, securing the two with bindings and adhesives. Each step required foresight and sequence. The addition of adhesives produced an explosion in possibility because brittle stone could be mounted and then used repeatedly. Maintenance of tools created prolonged returns on prior labor. Such innovations were often regionally specific, arising where ecological payoffs justified the investment. By 200,000 years ago, the map of hominin occupation across Afro-Eurasia was a complex patchwork. Some populations remained close to the equatorial homelands. Others had pushed deep into temperate and cold regions. Populations had diversified in body, habit, and culture. The capacity for fire-making, carried and maintained across travels, the invention and refinement of stone technologies, the habitual practice of shelter construction and clothing, all had enabled expansion and survival. At the same time, the record is a roll call of absences. Countless ventures left no descendants, and many local traditions flickered and vanished. The lesson of these migrations is not one of inevitable triumph. It is a lesson about narrow margins and patient improvisation. Movement creates exposure, and exposure demands invention. When hominins left the familiar soils of Africa, they did not arrive fully adapted to every place. They learned, slowly, to extend their bodies, tools, and social systems to new ecologies. Theirs was a long experiment in portability, of embers, of stone knowledge, of social habits that could be bent to new circumstances. In that experiment, chance plays a constant whirlwind, drought, the presence or absence of a cobble bed, the survival of a midwinter hearth. The archaeological and genetic fragments that reach backward across time show both contingency and resilience. Viewed from deep time, migration is not a cinematic exodus, but a rhythm of small commitments. A group sets off with a child on a hip and a few sharp edges in a bag. The child learns to sleep beside smoke, to recognize the ring of a familiar stone underfoot, to mimic a gripping motion that will be useful decades later. These are repetitions that aggregate into culture. They are acts of attention and care repeated at a scale of generations. The eventual emergence, much later, of symbolic languages and large-scale societal structures rests on these basic investments. The habit of carrying, of teaching, of keeping hearths alive across distance. In the end, the story of migration and adaptation between 8 million and 200,000 years ago is a story of becoming across geography. It is about hands learning new trades, bodies reshaping for cold, groups inventing shelters and social routines, and minds slowly rehearsing the temporal complexities of planning and sharing. It is a record of both tenacity and fragility. A species persistently trying out routes, sometimes succeeding, often failing, always learning. The world they entered was indifferent, but their persistent responses to that indifference laid the foundations for the later chapters. The dense webs of culture, the rich vocabularies of cooperation, and the eventual forms of cognition that would look back and ask the questions with which this narrative began. What does it require, in the mechanics of bodies and the patience of minds, for a species to turn a raw stone into an argument with the world? A deliberate act that demands not only hand skill but social coordination, planning, and a trust that others will keep the hour while one tends the task? Between roughly 400,000 and 200,000 years before the present, something like that argument was being made again and again across river terraces and sheltered caves, at hearths and on windswept plains. The technology changed, yes. Edges became anticipatory, hafts bound rock to wood, points were balanced and shaped. But the deeper transformation was social and cognitive. Tools became shared projects, hunts became concerts of timing, the small noises and touches between group members began to carry more precise meaning. In this interval, the material world and social life braided more tightly than before. The stone record of these centuries is at once technical and theatrical. Where earlier flakes had sufficed for opportunistic cutting, a new patience appears. Carefully prepared cores, planned removals, and the controlled production of predetermined flakes. The Levallois method, a choreography of strikes that prepared a core so that a single blow would produce a flake of predictable size and edge, is the archaeological expression of a mind learning to act several steps ahead. This is not a casual napping, it is the enactment of an abstract plan, a sequence held in thought and executed with practiced wrist tension. The act of preparing a core is itself a lesson in deferred payoff. Spend an hour shaping a block of stone to obtain a useful flake later. That temporal economy, invest now for benefit later, is a cognitive habit that underwrites more complex collective projects. Hafting shifts the story from single object utility to composite thinking. A sharp flake is useful. A flake fixed to a wooden shaft functions differently, as an integrated tool with a predictable trajectory and return. The traces of adhesives and the patterns of wear imply a technology that combined materials, stone and wood, sinew and pitch. Making a haft is a multi-step task. It requires choosing a shaft of elastic wood, shaping the stone point to fit, preparing bindings, and often heating or manufacturing a sticky resin to lock the parts together. Each of those steps may demand different skills, different specialists, and, crucially, communication. The moment a hand wraps sinew and another applies resin is an instance of cooperative manufacture. Bodies coordinating precise timing, force, and orientation. Those moments leave subtle marks on bones and tools. They also leave traces in social life because the knowledge of how to combine parts must be taught and repeated. Hunting large prey is where these technical and social transformations become most dramatic. Big game hunts are not solo events. They are choreography set to biological stakes, timing, role differentiation, mutual monitoring. Whether the prey is an aurochs, a wild horse, or an elephant like megafauna, taking such animals requires more than strength. It requires approach strategies, drives that herd animals into traps or toward concealed thrusting points, and a capacity to calibrate risk among group members. The archaeological record hints at such organized activity. Concentrations of butchered large mammals associated with dense tool scatters, patterns of cut marks suggesting coordinated disarticulation, caches that imply shared consumption. Imagine, as a way to make that evidence breathe, the hush before a coordinated drive. It is useful to avoid imagining named protagonists. Instead, consider the collective attention in a band. There is a pressure in the air. The slow, measured breathing of many bodies held close to the ground, the firming of grips around hafted spears. Eyes and ears are engaged in a mesh of signals, a hand flattening a body against a hummock, a discrete movement that redirects a peer, the low vibration of a whistle or a throat call that changes meaning by intensity and timing. The success of the hunt depends on calibrated timing and mutual trust. One misstep and the group risks injury, wasted effort, lost meat, or worse. The cognitive demands are therefore interpersonal. Individuals must predict not only animal behavior, but the likely actions of allies. They must remember past favors and slights, and they must act in ways that favor long-term coalitions. Those coalitions are social technologies as much as they are emotional economies. Food sharing after a successful hunt is not simply pragmatic. It is a means of redistributing risk, of cementing alliances, of managing reputation. When a group divides the spoils, who gets a front quarter and who waits for scraps is not random. The social calculus includes kinship, reciprocity histories, contributions to the hunt, and the presence of the weak or dependent. Sharing practices create obligations and expectations. They generate memory, the knowledge that someone once shared with me and that I, in future, may return the favor. Over generations, such routines become institutions, implicit rules about provisioning that stabilize group life and make cooperation more reliable. Caregiving also intensifies in this era. The archaeological yawns, healed fractures, skeletal pathologies showing long survival after incapacitating injuries, indicate that individuals were cared for when they could not contribute effectively. That care is costly, and to sustain it requires confidence in the group's capacity to provision and protect. The existence of long-term caregiving signals trust networks and social structures that value more than mere immediate return on investment. It is a social calculus that weighs the future benefits of maintaining skilled or knowledgeable individuals against present resource expenditures. Language, in its full modern richness, does not suddenly appear in a layer of sediment with a distinct label. But the social and technological pressures of these centuries made more elaborate communicative systems both useful and likely. Cooperative hunts, composite tool manufacture, and social provisioning create recurrent contexts that favor signals with higher informational content and greater reliability. Gesture and vocalization, used together, provide a multimodal channel for such information. This is a crucial point. Primitive language likely emerged not as words suddenly forming, but as a network of shared attention, referential gestures, and combinatorial vocalizations that allowed groups to coordinate over time and space. Joint attention, the capacity of two or more individuals to focus on the same external object and to use that shared focus as a basis for coordinated action, is central here. A pointing gesture to a distant flank, a lifted arm signaling "now," and a lowing call that cues a change in pace, all constitute a proto-grammar of behavior. The specificity required for complex hunts pushes communicative systems toward conventions. A particular whistle to signal retreat, a repeated hand sweep meaning drive left, an audible rhythm that paces a coordinated run. Over many cycles, such signals become conventionalized, learned, and embedded in social memory. They are the scaffolding of a language before language. Outside of immediate instrumental uses, symbolic behaviors begin to appear with more frequency and in more varied contexts. The use of pigments such as ochre, traces of which occur in sites of this age, hints at visual marking and possibly group identity. Deliberate modification of objects, not solely for utility but for display, begins to be archaeologically visible. These are faint beginnings of aesthetic and symbolic life, marks that endure beyond the ephemeral gestures of an encounter, objects that can be used to signal belonging, status, or memory. Ritual, in its earliest incarnations, is likely to have been small-scale, repeated manipulations of objects at shared places, careful deposition of particular remains, and perhaps acts of tending to the dead that extend beyond disposal and into remembrance. That remembrance matters. Mortuary practices are among the most compelling signals of social complexity because they are costly and oriented toward the non-utilitarian. When groups invest effort into placing the dead in particular positions, covering them with ochre, or keeping them in sheltered locations, they are performing an act that binds memory across generations. These acts stabilize narratives about group identity and continuity. They are social glue that extends beyond the immediate benefits of survival. Networks of exchange also expand in this interval. Materials travel across landscapes in patterns that suggest long-distance contacts. Non-local stone types at habitation sites, marine shells found far inland, pigments moved across valleys. Such exchanges are not mere resource flows, they are information flows. Trade creates relationships of dependence and reciprocity that enlarge the social field beyond immediate kin and neighbours. They permit the transfer of tool forms, of know-how, and of symbolic objects. Over time, such networks knit disparate groups into overlapping social worlds, and they create pressures for more generalized communicative systems because partners who do not share immediate habitual contexts still need to understand one another. The emotional overtones of life in these centuries are complex. There is excitement, the thrill of a successful coordinated hunt, the relief and warmth after meat is shared, the pride in a finely crafted haft. There is fear, the palpable dread of a misjudged spear, the anxiety of hunger when seasons fail, the grief when care cannot save an elder. Beneath both, there is a persistent cognitive labor, the continuous updating of reputation scores, the mental bookkeeping of favors and debts, the rehearsal of skilled sequences that must be reproduced accurately to yield future benefits. These affective tones are not literary projection, but emergent properties of systems where survival depends on repeated, reciprocal, and coordinated acts. Against this canvas, technologies and social practices feed one another. Better tools make more reliable hunting possible. More reliable provisioning makes extended caregiving plausible. Caregiving and teaching produce more skilled artisans. Skilled artisans produce better tools, and better tools widen ecological opportunities. The loop tightens. It is not a teleology toward modernity, but a feedback system in which certain behaviors amplify others and create niches that favor further elaboration. There are also contingencies bluntly present. Climate fluctuations, the extinction of favored prey, the chance loss of key innovation holders, or the arrival of competing groups could halt or redirect trajectories. A band that develops a sophisticated hafting method in one valley may be wiped out by disease before the technique spreads. Another band, less technically adept, might persist by virtue of demographic luck. The archaeological record is scattershot in exactly this way, layered proof of both invention and loss. What survives into later chapters is the intersection of innovation with demographic stability and social networks that permit transmission. By 200,000 years ago, the scene across Afro-Eurasia shows patches of recurring complexity. Prepared, core technologies more widespread, hafted implements in many regions, habitual large-game hunting strategies, networks of raw material exchange, mortuary behaviors, and increasingly conventionalized communicative repertoires. Those threads form an ecological and social fabric that makes new possibilities thinkable. Durable hafted armatures used to project force at a distance, shared protocols for mobilizing groups across a landscape, conventions that allow strangers to negotiate exchange, and semi-formalized knowledge transmission systems that scaffold apprenticeship. In the end, this is a story of accretion and mesh. Tools are not only objects, they are social acts frozen in stone. Bandit hunts are not only episodes of violence, they are sustained performances of timing and trust. Proto-language is not a sudden blossom, but a slow ratcheting of joint attention, referential signals, and combinatorial vocalizations that together make coordination more reliable. The period between 400,000 and 200,000 years ago is an episode in which material culture and social bonds co-evolve. Each invention presses outward on social life, and each social innovation enables more complex material practice. It is a time when the human project ceases to be merely a set of bodily adaptations and becomes increasingly a project of shared intention, a collective experiment in shaping the world in order to shape each other. What happens when a species learns not only to live in a world of objects, but to wrap meaning around them, to assign invisible weights and names that no longer vanish with the body that first anchored them? What changes in the architecture of a mind when it can imagine things that are not present? Ancestors who died months ago, seasons yet to come, or birds that belong as marks on a wall rather than as meat on a bone? These are not idle metaphors. They are the questions that dominate the centuries when Homo sapiens emerges and when symbolic thinking takes hold. A long, subtle revolution in which brains, gestures, pigments, and stones conspire to produce a new ecological niche. One of shared meanings and imagined realities. Part 9. Rise of Homo sapiens 300,000 years ago. The emergence of Homo sapiens is not a sudden knock at midnight. It is a slow redescription of capacities already in motion, cranial shapes that curl and expand in different proportions, cortical folding that allows more parallel processing, microarchitectures within the prefrontal cortex that favor longer planning horizons and more flexible behavior. Around 300,000 years ago, in pockets across Africa, populations began to exhibit the anatomical traits that would later be identified as characteristically human. Faces that sank back beneath broad foreheads, skulls rounded in a way that enlarged associative cortices, jaws that adjusted to diets mediated by new technologies and cooking. These anatomical shifts were the visible end of invisible processes. Loads of small changes in life, history, diet, social organization, and material practice that rerouted developmental trajectories across generations. Anatomy is only a scaffold. The deeper change lay in how information was treated. Brains enlarged and reorganized in ways that did not simply add raw processing power, but reallocated it. The tissue devoted to sensory processing remained essential. The hands still learned by touch, the eyes still passed color and shape. But tissue devoted to cross-modal integration and to holding temporal chains in mind expanded. Working memory, the ability to keep a sequence of actions or a contingent plan active while executing the next step, gained capacity. That increment is quiet but enormous. It makes possible multi-stage tool manufacture, cooperative strategies that require precise timing, and the kind of storytelling that stitches past into present. Alongside neurological changes, life history changes mattered. Longer juvenile periods, extended parental provisioning, and social networks that tolerated non-productive individuals for longer created ecological space for prolonged learning. Young bodies spent years practicing the motor sequences and social rituals their elders enacted. Those years were laboratories for embodied knowledge. In this context, cultural practices, skills, norms, stories could become inherited not by genes, but by patterns of attention and repetition. The habit of sitting by a fire and watching an elder shape a point. the repeated choreography of cooperative scavenging and butchery. All of these were mechanisms of transmission that multiplied cognitive investments across generations. Material culture in this time grows more complex, more networked. Stone technologies refine into more standardized forms, hafted implements become common, allowing force to be projected while reducing individual strain. But more than tools were being made. Small objects, portable and intimate, start to appear with increasing frequency. Beads made from shells, tiny perforated bones threaded by fiber, ochre-stained fragments kept in pockets. These objects are not mere decoration, they are portable semantics, tokens that encode relations, affiliations, or events. A perforated shell is a claim, a memory, a broadcast. When such objects circulate between people, they create webs of shared attention and shared value. They become durable nodes in social networks, objects that outlive the fleeting presence of any one body and thereby stabilize patterns of association. Burial practices begin to change in ways that reveal internal life. Where earlier disposals of the dead may have been pragmatic, the late Pleistocene shows repeated instances where bodies are placed in particular orientations, sometimes with pigments or with objects laid nearby. Such behaviors are not necessarily signs of theological systems in the modern sense, but they do reveal an incipient concern with remembrance, an awareness that the dead can be marked in ways that speak to the living. Marking a burial with pigment or placing a bead beside a body transforms a moment of loss into a durable social act. It says, "This life mattered, we will not let it be erased. The cultural consequence is enormous. Memory is externalized, and the social field extends beyond immediate pragmatic needs into networks of representation." The sensory world of these early Homo sapiens is thick with new affordances. Pigments stain skin and hide, making the flicker of a fire more than mere warmth. It becomes a stage where faces can be made more visible, identities accentuated. The smell of smoke, previously a deterrent, becomes an atmospheric common good that marks a lived place. The tactile satisfaction of a bead against the collarbone, the sound of shells clacking softly against clothing, the visual language of patterned lines on a bone. These are small sensory anchors for larger narratives. In aggregate, they create a culture of external memory, objects that cue stories, songs, and duties beyond the immediate now. Yet Homo sapiens did not arise in a vacuum. Networks of exchange, of stone, shell, pigment, crisscross landscapes long before written lines are drawn. Long-distance transport of exotic materials signals not only curiosity, but the existence of systems that value such objects. It is the material echo of social connections that span hundreds of kilometers. When a particular kind of flint from a distant quarry is found far from its source, it testifies to journeys, both literal and social. Someone carried knowledge, someone else accepted objects as meaningful, and in those exchanges, social conventions deepen. Emotionally, the rise of Homo sapiens reads as a sharpening of collective states. There is more attentive curiosity toward opaque things. There is more capacity for sustained mourning and for commemoration. There is an increased proclivity toward making objects that speak across time. These shifts are not simply psychological novelties, they restructure social life, creating obligations and expectations that guide behavior in predictable ways. The advantage is clear. Groups capable of bonding through shared symbols, of remembering alliances and slights, and of teaching complex skills across long juvenile phases, gain resilience in uncertain environments. Part 10. Symbolic Thinking. This 100,000 and 40,000 years ago. If the rise of Homo sapiens provides the biological soil, the flowering of symbolic thinking is the cultural bloom. Between roughly 140,000 years ago, the archaeological record increasingly accumulates evidence that humans were not only making useful objects but investing them with meanings that transcend immediate function. This is the interval often associated with an explosion of representational acts. Engravings, geometric motifs, painted images, personal ornaments worn not just for utility but to signal belonging, status, or memory. The crucial novelty is not the object itself, but the cognitive operation it embodies. Representation of an absent referent, the capacity to treat a mark as standing for something else. What does a symbolic act feel like in the body of a species? It begins with attention held longer than the present, with a mind able to simulate absent states. A mark on a rock is not the bird that once flew, it is a cue for an idea about that bird. The making of that mark requires motor control and an anticipatory imagination. The maker must intend a form and then execute a sequence of strokes to achieve it. The social dimension magnifies the act. Shared symbols are efficacious only if others recognize them. Thus, symbolic systems require conventions, stable mappings between sign and meaning that are learned and reinforced. This social conventionalization is the engine that turns individual mimesis into culture. The archaeological traces are varied and evocative. Engraved patterns on ochre, the earliest abstract designs, are often composed of deliberate incisions, scratches that follow a rhythm and an intent. These are not accidental marks, they are patterned, repeating motifs. In caves and on portable blanks, pigments now appear in chromatic arrays: red, yellow, black, applied with hands, brushes, or blowing techniques that suggest planning and tool use. The image of an animal painted on a dark interior panel is also an act of communal attention. Such places may have been dark when first painted, illuminated by the same fires that made tools, and the act of painting there may have been a shared social event, a ritualized performance of memory or identity. Personal ornamentation becomes widespread. Shell beads perforated and strung, notched ivory, and pendants carved from bone are found in contexts that suggest they were worn. Such objects function as social signals in a dense fashion. They declare affiliations, histories, the ability to access resources, or the capacity to maintain network ties. A bead is portable and readable. Worn on the body, it becomes a mobile index of identity. The social consequences are profound. Once identity can be signaled in durable, portable ways, it opens pathways for long-distance recognition. A token from one valley can be read by someone in another, creating a web of mutual recognition and trust that transcends immediate kinship. The development of symbolic thinking also reshapes communication. Language, already emergent in its biological roots, now finds new external supports. Symbols permit the externalization of reference. Objects and marks can stand for absent persons, places, or events, easing the burden on memory and enabling more complex joint planning. The capacity for narrative grows in tandem. Events can be ordered, told, and rehearsed. The consequence is cultural memory that accumulates across generations. Songs, myths, and ritual behaviors, while invisible in rock, may be inferred from patterns of repeated marking, the locations of repeated activity, and the standardization of certain object types. Technology and symbolism co-evolve. Composite tools become more elaborate, hafted points are refined, and the production of barbs or serrated edges indicates an understanding of material mechanics and the needs of particular prey or tasks. These technical advances are not separate from symbolic life. A decorated spear, or one bearing a distinctive motif, is both a tool and a statement about personhood, about group membership, about lineage. The mark on a tool can be read as reliably as the mark on a pendant. In this way, technological artifacts become carriers of social information. Burial practices in this period become more elaborate and more regionally varied. Some interments are accompanied by grave goods, ornaments, pigments, carefully prepared deposits that imply concern with afterlife or with maintaining the social presence of the deceased. The act of burying with objects is an explicit example of symbolic thought. The living create a material statement about the dead, asserting values or social roles beyond death. Whether these acts represent proto-religious belief or social signaling of status is often impossible to disentangle, but both interpretations rest on the same cognitive substrate: the capacity to treat absent states as meaningful and to structure actions accordingly. The effective atmosphere of symbolic life is dense. There is awe and reverence, certainly, but also the pragmatic use of emotion as social glue. Symbols organize communal attention and emotion. A painted panel can unite a group in a shared glimpse of ancestry or cosmology. A bead exchanged can create obligations. A burial rite can consolidate mourning into a social script. The management of emotion through symbols is an adaptive tool. When fear, grief, and affiliation are routinized into shared practices, groups can coordinate responses to threats and bond across periods of scarcity. Symbolic culture is thus both expressive and instrumental. A crucial cognitive innovation tied to symbolic thought is the capacity for shared intentionality, the understanding that others have purposes and that goals can be pursued jointly. Joint projects, hunting strategies that require coordinated drives, construction of complex traps, the staging of ritual events depend on this capacity. Notably, joint intentionality requires not only theory of mind, recognition of others' mental states, but also public commitments, conventions that specify what is intended and what counts as fulfilling that intention. Symbols help stabilize such commitments. They make intentions visible and therefore accountable. Symbolic thinking also transforms memory. External media objects, marks, pigments, function as memory prostheses. The presence of a painted motif or a bead makes a memory retrievable. It reduces the cognitive load of maintaining large inventories of social information internally. This externalization permits the accumulation of more complex traditions because knowledge does not have to be retained wholly within each individual. It is stored across objects and places. That distributed cognition allows societies to build longer, more intricate chains of transmission technologies that require cumulative refinement across generations, myths that explain why certain territories are sacred, and social rules that govern exchange across distances. The same processes that produce cohesion also enable differentiation. Symbols are tools of distinction as much as union. When groups adopt particular styles of ornamentation or specific motifs in marking, they create boundaries, visible, portable boundaries around identity. These markers can be used to include or exclude, to cement alliances, or to mark rivals. Thus, symbolic culture is a double-edged sword. It fosters larger cooperative networks while simultaneously creating sharper axes of social competition. The material record for this interval is geographically patchy but thematically consistent. In many regions, humans are repeatedly marking, ornamenting, and burying. In caves, in open-air shelters, alongside river terraces, there are objects and marks that refuse to be purely functional. They are choices made with an eye towards social life. And the pattern is not limited to Homo sapiens narrowly defined. In some regions, other hominin groups engage in similar behaviors, suggesting that symbolic competence may have been distributed among multiple lineages or that cultural transmission crossed species boundaries through contact. Symbolic thinking is not magic. It is rehearsal and repetition, fused with the capacity to imagine absence and the social incentive to maintain shared meanings. It grows from many small acts: the deliberate incision on a piece of ochre, the careful perforation of a shell, the patient layering of pigment on rock. Each small act is social insofar as it presupposes other minds that will recognize and respond. Over tens of thousands of years, these acts accumulate into landscapes of meaning, caves that are not only shelters but shrines, objects that are not only tools but signifiers, bands that are not only foragers but carriers of narratives. Viewed from the long arc of deep time, symbolic thinking changes what it means to be part of the world. It permits humans to make commitments to future states, to plan across generations, and to create worlds that are as much imagined as they are given. Where earlier epochs scoured the planet with selection for bodies and sensory worlds, this period begins to sculpt selection from minds that live in shared representations, minds that build commons of meaning as reliably as they build hearts. Such minds can coordinate at larger scales, accumulate cultural capital, and imagine futures in which their descendants will recognize the signs left behind. The story is not linear or inevitable. Many small experiments in symbolism failed to persist. Many populations left no enduring marks. But the cumulative effect is unmistakable. By 40,000 years ago, the world is dense with human-made symbols, an overlay of meaning that future generations can read, debate, and inherit. This cultural overlay becomes a new kind of environment, one that shapes, in return, the cognitive architectures of those who grow within it. And so the narrative folds forward. Bodies that once learned to stand and carry now invent systems of memory and identity. Hands that first struck stone to eat now mark rocks to remember. The emergence of Homo sapiens and the subsequent flowering of symbolic thought are not discrete miracles, but the slow accretion of practices that reconfigure the relationship between mind, matter, and meaning. The next chapters will trace how those symbolic capacities densified into myths, institutions, and technologies that would reshape the planet's social topography in ways impossible to foresee from the flicker of a single hearth. What is a person without a story? What happens when a species capable of bearing witness decides that absence is not merely empty space, but a place where meaning might dwell? The first time humans arranged a body with care, smeared pigment across a skull, or suspended a shell from a cord, they were doing something more than burial or ornamentation. They were inventing a way of extending presence beyond biological life, a cultural technology that would alter how knowledge, grief, and obligation were carried through time. The archaeological hints are small and stubborn: a skeleton placed with hands folded, traces of ochre dusting bone, a few beaten shells gathered in a cluster. These are not dramatic declarations so much as delicate notes that, when read together, suggest an emergent practice. Around the late Pleistocene, and in a few key earlier moments, human groups began to ritualize death. Bodies were not left where they fell. They were prepared, arranged, and sometimes accompanied by objects. The actions were tactile and deliberate. Flesh was washed or scraped, hair might be tied or braided. The dead were placed on prepared ground on their side or back, often in a curled posture that mimicked a return to womb-like safety. Ochre, a pigment of iron, stained bone and cloth with the color of dried blood and earth, a visual marker that said, "This person matters." To reconstruct these acts in imagination is to fill the silence with texture. The scent of smoke from a small hearth, the earthy metallic tang of ochre ground between stones, hands careful and unfamiliar with this particular choreography. These are the details that convert a sterile site into a social scene. There is the low hum of a group gathered close. their movements coordinated by habit and affect rather than instruction manuals. Someone positions a bracelet, another smooths a hide, and a child watches with a gravity that seems older than words. These are not fictional tableaux of named protagonists. They are the plausible choreography of communal attention, repeated until the procedure itself takes on the force of convention. Why did such rituals arise? The simplest answer is psychological economy. Death introduces uncertainty about what will be remembered, who will inherit tools and territories, and how social bonds will be sustained when bodies are gone. Rituals answer these uncertainties by externalizing memory. They provide material anchors for recollection, a bead that can be touched, a painted cave wall that can be re-entered. In doing so, rituals convert fleeting grief into collective practice, binding individuals into networks of shared obligation. The act of burial is therefore both consolation and communication. It comforts the living and signals to the group that certain losses will be acknowledged, storied, and taught. The cognitive prerequisites for this shift were subtle but profound. Earlier episodes in human evolution had fashioned the neural hardware for joint attention, symbolic reference, and prolonged childhoods, the very conditions under which ritual could emerge. Shared attention allows a group to focus on a single object or event, and to use that shared focus as a platform for teaching and remembering. Symbolic reference permits a mark or object to stand in for an absent person or idea. Extended juvenile learning provides the time necessary to pass on ritual scripts. How to prepare a body, which words or gestures to pair with offering, which pigments connote particular meanings. Under these conditions, human groups were able to develop practices that were not merely adaptive in an ecological sense, but adaptive in a social, mnemonic one. Belief in the supernatural grows naturally out of these practices. When objects can stand for people, and people can be represented in durable materials, the mind begins to conceive of action and intention in absent agents. Ancestors, once remembered repeatedly at hearths and in graves, can become social actors in their own right. Sources of guidance, sources of wrath, guarantees of lineage. The leap from treating a burial as a sign of respect to treating an ancestor as an ongoing presence is a small cognitive step, but a large social transformation. It endows the world with invisible agents, winds that have will, animals that carry omen, places that are inhabited by memory, and it provides a framework for explaining misfortune, for regulating behavior, and for creating moral obligations that extend beyond immediate reciprocity. Rituals are, in this sense, technologies of trust. They solve collective action problems in a way that biology alone cannot. A group that stabilizes rights around sharing, for example, can coordinate care for non-producers, protect the elderly, and enforce norms of cooperation through reputational memory. Imagined ancestors can sanction freeloaders and reward the generous through subtle social mechanisms. The mere belief that one's deeds will be observed by remembered others encourages pro-social behavior. Thus, the supernatural is not merely misty metaphysics. It is a functional scaffold that makes larger social groups possible without genetic kinship as the sole organizing principle. Oral transmission is the engine that carries these rituals across generations. Long before writing, the mouth was the primary medium of cultural continuity. Story, song, and carefully performed ritual scripts embed ecological knowledge within mnemonic forms that the human brain excels at retaining. A story about a dangerous marsh, embellished with characters and consequences, is a more memorable map than a list of do's and don'ts. Songs carve sequences into rhythm and melody. They make routes, seasons, and taboos memorable in a way that raw instruction does not. Thus, myths often encode practical knowledge, which plants are edible when cooked. What wines lie before certain ridgelines, which animals migrate at particular moons. Embedded within moral tales are heuristics for survival, and through repeated telling these heuristics are conserved and refined. Inside the hearth-centered pedagogy, learning is embodied. Children do not simply hear a story, they are circled by it. An elder may rhythmically clap a stick to mark the steps of a migration song. Another may point to the map on a hide and trace the route with a careful finger. A third may pantomime the stalking of a deer while the group breathes in time. The cumulative effect is dramatic. Knowledge becomes portable and social. It is no longer bound to individual memory, but distributed across the voices and bodies of the group. This distribution is the true advantage of oral culture. It makes cultural accumulation robust to the death of any single teacher and allows innovations to diffuse more rapidly across networks. The structures of such oral transmission are themselves ritualized. Rehearsal is obligatory. Memories must be practiced in the presence of witnesses. The act of correcting a novice is often performed as a rite, a story retold with adjustment, a song lengthened, a gesture sharpened. These rehearsals create standardization. Over generations, a set of correct techniques and narratives becomes an inherited repertoire. The effect is cumulative culture. Each generation inherits not only the accumulated stock of knowledge, but the social mechanisms for preserving and selectively modifying it. This cumulative process is what allows technologies and rituals to become increasingly complex without the necessity of genetic change. Material culture and memorial practice intertwine. Portable objects, beads, pendants, carefully shaped points, become mnemonic tokens. They can be passed as heirlooms, their presence signaling affiliations and histories. A shell on a cord tells a story of where a person's network reaches. A patterned spear butt marks a clan's skill at hunting. A painted motif on a rock ties a lineage to a place. These objects are durable reminders that encode social relationships in a distributed, externalized manner. They do for memory what caches do for food. They store value that can be retrieved when needed. The consequences of these practices are visible in the archaeological record beyond burial. Painted caves, engraved ochre, and standardized ornaments suggest a world in which shared symbols had social power. Symbols enable wide-scale cooperation by providing common reference points. A painted motif recognized across a landscape normalizes certain behaviors toward a place, an ornament style, signals alliance and thus facilitates trade and hospitality. Over time, such shared symbolic repertoires allow groups to coordinate at scales much larger than the band. Seasonal aggregations, ritual centers, and even incipient forms of social hierarchy. Emotion weaves through all of this. Ritual is not only intellectual architecture, it is affective architecture. Grief is organized by ritual. Fear is mitigated by communal acts, and hope is transmitted through stories that bind past suffering into narratives of resilience. The very act of gathering to mark a life, to chant a song, or to paint a panel is a social regulation of feeling. These collective acts produce emotional synchrony, which in turn reinforces group cohesion. People who cry together, who chant in time, who perform the same gestures are more likely to cooperate later. Emotion thus becomes a tool in the social kit. It stabilizes memory, polices behavior, and creates durable affiliations. It is worth pausing on contingency. Ritual and belief systems did not arise everywhere at once, nor did they follow a single trajectory. Many groups may have practiced simple disposals with no accompanying symbolism. Others developed rich rituals. Still, others abandoned particular rites in the face of migration, resource change, or social breakdown. The archaeological record preserves a mosaic of practices, some that persisted and radiated, others that flickered and vanished. The evolution of ritual and religion is not a ladder leading inevitably to complexity, but a web of experiments, some amplified by demographic or environmental advantage, others lost to time. There is also a flip side. Symbolic systems can tighten social boundaries as easily as they can extend them. As groups create markers of identity, styles of ornamentation, burial customs, ritual pantheons, they simultaneously carve lines of inclusion and exclusion. Symbols that promote cohesion within a band can create distrust of outsiders, and those boundaries can harden into conflict. In this sense, the invention of the supernatural is ambivalent. It makes larger, more organized societies possible, but it also introduces the cultural machinery that can divide. The moral content of these systems is not predetermined, it is forged through use. And so, the age-old human task of memory and imagination became institutionalized. The repeated rituals, the carefully guarded songs, the painted panels, and the beads on a cord made absent relations tangible. Oral tradition, as a daily pedagogy, permitted the slow accumulation of adaptive knowledge. Roots, recipes, rituals, taboos. Symbolic thought allowed facts to be steeped in meaning, to be bound to moralities and myths that made them sticky across lifetimes. Together, these capacities rewired human social ecology. They allowed groups to trust in stories, to coordinate beyond immediate reciprocity, to store information outside of the fragile register of individual remembering. Viewed across the expanse of deep time, these small domestic acts amount to a revolution. Not the single lightning flash of discovery, but the steady making of a social technology that would enable cities, laws, and cosmologies. From the first ochre-dusted grave to the complex ritual theatre of later epochs, humans learned that the world could be shaped not only by hand and fire, but by narrative and belief. They learned that absence could be made to bear meaning, and that memory could be externalized into objects and actions that outlast any single life. In the hush that follows these reflections, one may imagine a child centuries later touching a bead whose bead hole has been worn smooth by many fingers. That touch is an unbroken line, a physical contact with an act of remembering that once began as a small improvisational gesture and grew into a scaffold for knowledge and society. The human capacity to imagine the unseen, to ritualize the passing of bodies, and to transmit guidance through oral forms is not merely a cultural flourish. It is the mechanism by which experience accumulates across generations, by which lessons survive, and by which a species turned its fleeting lives into a durable, if fragile, heritage. What does a world sound like when speech stops being a tool for immediate survival and becomes a medium for thought itself? What changes when words can hold not only the urgent facts of where to find water or how to avoid a cliff, but also songs, laws, imagined kin, and futures that extend beyond the lives of those who speak them? This is the question that shadows the long hinge between roving bands and settled places, the slow era, when language attains a precision and a social reach that reshapes landscapes, bodies, and the very notion of what counts as human dominion. The refinement of language is not a single invention, but a cumulative sharpening. Over generations, a grammar of deferred reference and shared intentionality grows robust enough to carry complex plans, to encode roles and obligations, and to create narratives that bind people across months, seasons, and years. With more elaborate syntax and larger vocabularies, communities could compress long causal chains into instructions, networks of tasks that combine many hands over days, the coordination of hunts involving dozens, The staged construction of shelters meant to last through winters not just for one family but for an assembled group. Language becomes the technology that can hold a process in mind before it exists in the world. That capacity to describe, rehearse, and critique a multi-stage sequence catalyzes a cultural flowering. Where earlier societies transmitted practical skills by demonstration beside the hearth, now they accompany demonstrations with names, categories, and rules. Objects acquire fixed identities within a shared lexicon. This shell is not merely a shell, but a badge. That pigment is not merely red clay, but a token of lineage. The advantage is subtle but profound. Name and convention crystallize expectations, reduce ambiguity, and permit cooperation at scales impossible for unmediated gesture alone. Someone can be tasked to return to a cache in 3 moons. They can be reminded by a word, the community symbol, rather than by the fragile thread of individual memory. Memory itself becomes partially externalized, anchored in language as much as in objects. Art, once intermittent and local, spreads with renewed intensity. Painting moves from the privacy of a few sheltered panels to a more varied repertoire. Ephemeral body painting for ceremony, permanent motifs on habitation walls, and portable decorated objects that travel with people across valleys. The act of applying pigment becomes a public grammar. A painted motif signals more than aesthetic preference. It communicates identity, role, and seasonal duties. Likewise, music and instrument, making evolve in complexity. Where a rhythmic call once coordinated a hunt or a gathering, now crafted instruments. Flutes of bone, stringed rigs of gut and wood, percussion of hollowed logs, allow modulation of timing, melody, and collective memory. Music becomes both a mnemonic scaffold and an effective architecture. Patterned sound organizes emotion, synchronizes groups, and amplifies the social glue that rituals require. The soundscape of these communities changes the quality of social life. A flute's long, mournful note can hold a mourning ritual through the cold hours. A drum pattern can steady hundreds walking to a seasonal aggregation. A chorus of voices can transmit a genealogical roll call that ties a newborn to ancestors whose names, once only ephemeral, are now fixed in narrative. Instruments are not mere toys. They are technologies for synchronization, temporal devices that permit many minds to move as if they shared a single pulse. This capacity to coordinate feeling at scale makes certain social configurations possible. Larger cooperative hunts, communal construction projects, and the management of stored resources over seasons. Hunting strategies themselves inherit the benefits of refined language and organized culture. Complex drives, once improvised, become choreographed performances. Herd animals are funneled across the terrain by networks of people, positioned with calibrated timing, decoys and noise. Makers divert attention, buried pits and concealed barriers channel movement. This technical calculus requires more than individual skill. The coordination demands roles that are rehearsed and remembered, signals that can be trusted, and shared incentives to keep commitments. As hunts scale up, specialization follows. Some individuals become expert trackers, others master butchery. Some learn to maintain adhesives and hafting. These functional specializations propagate social hierarchies and reputations. It matters who tends the child while others stake out the line. It matters who holds the knowledge of the best snares and where to find lithic material. Perhaps the most decisive transformation is the shift from mobility as a rule to permanence as a strategy. Food production, initially experimental tending of wild stands, the encouragement of favored grasses and tubers, the selective protection of plant patches, begins as incremental manipulation of ecosystems. People plant and protect, they prune and scatter, they fence and burn. Over generations, those manipulations intensify. Where previously mobility allowed for risk spreading across patchy resources, deliberate tending concentrates labour and creates stored surpluses. Surpluses enable new habits. A portion of the group can pursue non-subsistence crafts such as weaving, pigment preparation, instrument making, and ritual specialists who maintain the mnemonic and symbolic systems. Storage itself becomes technology, silos, pits, and caches that require rules for access and maintenance. When food accumulates reliably, population densities rise. Denser populations favour denser social institutions. Language refines in parallel with production. Legal phrases and norms crystallize. Words that delineate ownership, that circumscribe obligations to neighbours, that formalize penalties for transgression. Social memory, encoded in myths and ritualized speech, stabilizes property and kinship claims. If a strip of land is to be defended across years, the narrative that ties a lineage to it must be repeatable and convincing. A poem of descent becomes a charter of tenure. Thus, myth and law fuse, and with them the emergence of enduring social roles, elders as repositories of custom, ritual specialists as interpreters of precedent, and craftsmen as hereditary custodians of technical knowledge. That codification of human relations is a two-edged phenomenon. On one hand, it enables cooperation at scales that allow landscape transformation, irrigation systems that distribute water across fields, planned storage enabling seasonal calorie smoothing, and the coordination of labour to move stones or earth projects whose returns would be impossible without long-term planning anchored by social convention. On the other hand, the very fixity of obligations and property creates inequality. Where kin-based sharing had been a flexible norm in highly mobile bands, sedentary surpluses enable the accumulation of possessions, the establishment of prestige, and the emergence of leaders who can marshal labour and command allegiance. These leaders often derive authority from ritual knowledge and the guardianship of symbolic goods, the very objects and performances that create shared meaning. Domestication, then, is both practical and emblematic. Animals that once supplied unpredictable meat become managed herds. Selective breeding reduces flightiness and increases docility. Plant species exhibit morphological changes under human stewardship. Larger seeds, thinner husks, signs of millennia of co-evolution. As humans shape other species, they reshape ecological networks. Patches of wild landscape are converted into anthropogenic biomes. Fields, orchards, and managed groves replace heterogeneous mosaics. The planet responds. Soil composition changes under cultivation. Sedentarism compresses local biodiversity in favor of taxa that tolerate disturbed ground. The hand that once gathered scattered fruits now tends furrows of grain, and with that change comes the accumulation of environmental power. Power manifests in the capacity to outcompete other species for primary productivity. Humans begin to appropriate sunlight and soil at scales previously unimaginable. Where hunter-gatherers subsisted on fractionated calories and seasonal abundance, agrarian communities redirect flows of energy toward human bodies and their domesticated companions. The effect is dramatic in deep time. Human populations grow, and their ecological footprint expands. Trade networks carry surplus food across regions, enabling populations in marginal zones to stabilize and intensify further. Humans become architects of ecosystems, a novel force on Earth's stage. That dominion is not uniform or absolute, it is a gradient built from innumerable local choices repeated and scaled up. Cultural expression intensifies in tandem with domination. Music and painting become not only repositories of identity, but instruments of governance and cohesion. chants, and played sequences encode work rhythms for fields and canals. Songs transmit calendrical knowledge. When to sow, when to harvest, painted murals display mythic orders that legitimate rulership. The palace and the temple become intertwined spaces where symbolic performance sustains political will. Art is enlisted to render abstract social relations visible. Lineage lines painted on walls, depictions of mythical battles that justify expansion, musical forms that coordinate labor and ritual. The interplay of aesthetics and authority consolidates social structures that can marshal vast coordinated efforts. Yet the growth of this dominance also introduces new vulnerabilities. Sedentism concentrates waste and disease. Higher population density fosters pathogens that previously could not sustain chains of transmission. The energetic surplus that allows some to pursue craftsmanship and ritual also creates dependence. A breakdown in irrigation or a bad season can lead to starvation at scales previously impossible. Social stratification sharpens conflict. Competition over prized lands and resources occasionally escalates to organized violence. Language and symbolic systems, while enabling cooperation, also refine ideologies that sanction domination stories that justify the privileges of the powerful and ritual forms that bind laborers to obligations. Human domination of ecosystems is thus a story of increased capacity and increased moral complexity. The cognitive and cultural investments that propel this transformation are not morally inevitable. The same processes that enabled cooperation at scale, shared symbols, ritualized bonds, institution-forming myths, also create the machinery for exclusion and hierarchy. The development of musical instruments and painting, the perfection of language, and the sharpening of hunting into logistical spectacles are all expressions of human ingenuity. They are also tools that can be used to concentrate power and to marginalize. The narrator's task in Deep Time is to observe both capacities without teleology, to note the extraordinary creativity and the shadow it casts. Across the centuries of this threshold era, several themes reoccur with quiet insistence. First, the externalization of memory words, marks, objects, pigments, rhythms, allows social information to persist beyond single lifetimes and to be transmitted across distance. Second, technologies that begin as individual crafts, hafting, baking, textile making, instrument crafting, become social practices reproduced by apprenticeship and ritual. Third, the scaling of cooperation, facilitated by language and ritual, enables humans to undertake projects that transform landscapes and biomes, making them, in a real sense, the planet's dominant engineering species. The emotional texture of the era is paradoxical. There is exhilaration, new songs, new objects, the novelty of shared rituals that elevate ordinary days into remembered events. There is also anxiety, the accrued responsibilities of those who must maintain embers through winter, the quiet stress of tending fields that will fail if timing slips, the social tension of inequity. And beneath these more human affective tones flows an older current of contingency. The domestic settlement is more susceptible to droughts, to pathogens, to social collapse. It is powerful, yes, but precarious. The story is not one of ascending mastery, but of augmented agency, coupled with new fragilities. By the time communities transform into early polities with fixed places, specialized crafts, and symbolic architectures, humans have become a defining agent in ecosystems. Instruments are played in courtyards beside granaries. Pigments are mixed in workshops near channels. Hunting strategies have been codified into seasonal expeditions supplemented by herds kept for draft and food. Language is precise enough to define laws and to debate obligations. Culture explodes into variety. Music and painting flourish alongside technological refinements and religious systems that sacralize certain practices. In the interstices of these developments, humanity's domination of the biosphere becomes a lived reality, visible in terraced hillsides, irrigated valleys, and networks of exchange that tie regions together. The narrative at this point is both accomplishment and cautionary tale. The human capacity to coordinate, to symbolize, and to shape living systems is breathtaking. Yet the same capacity reinscribes new inequalities and ecological pressures that will have long reverberations across the planet. This is the threshold, from bands whose memory was oral and whose reach was local, to societies that keep accounts, that play music deliberately to regulate large groups, that paint grand narratives that justify expansion, and that manage landscapes at continental scales. It is an age in which language, finely refined into a versatile instrument of thought and coordination, proves both a creative force and a responsibility heavy with consequences. If the story of deep time is a meditation on contingency and creativity, this chapter underlines a central paradox: the very behaviors, precision of speech, ritualization of grief, the invention of song and pigment that allowed humans to flourish also set in motion planetary transformations whose outcomes remain undecided. The rise of culture and the instruments of meaning made humans architects of ecosystems, but architects must also reckon with what they build. The next chapters will follow how these newly potent social machines, languages, arts, and coordinated economies are woven into myths and institutions that will shape civilizations for better and worse across the subsequent millennia. What does it mean for a planet of foragers to learn that abundance can be stored, that the season's mercy can be negotiated with labor, and that patience, rigid, repetitive, communal labor, can convert ephemeral bounty into durable systems? That question frames the last act of the long human story. The slow shift that begins, unevenly and in multiple places, roughly 12,000 years ago, and reaches outward into the household, the city, and then the abstract architectures of law and script. This is not an origin myth. It is a meditation on how small domestic decisions, burying a seed, saving a stalk, teaching a child to tend a patch, unlocked new tempos of life and new scales of thought. In the immediate aftermath of the last ice age, climates settled into rhythms that were, by geological standards, congenial. Where pulses of cold and drought had once made long-term settlement hazardous, the Holocene offered pockets of relative predictability. Those pockets were not vast deserts of security but narrow opportunities, wetlands that run longer into the dry season, river margins where nutrient-laden silt renewed itself, stands of wild grasses that responded to deliberate reaping. Gradually, across the Fertile Crescent, in the Yangtze and Yellow Rivers, along the coasts of the Americas, and in the uplands of New Guinea, people began to take what had been accidental association with certain plants and animals and turn it into relationship. They coaxed, selected, protected. They planted where they had once only harvested. The action of sowing is a small miracle, repeated thousands of times. One can imagine the tactile choreography: hands raking grit into loosened earth, fingers pressing a seed to a place that promises moisture, a body bending over a plot in the same arc summer after summer. That repetition, the act of returning to the same patch, of clearing, of weeding, creates an environment where the plants themselves change. Selection follows practice. Grasses that once cracked when threshed become plumper, husks soften, and spikelets hold their grain until harvest. Simultaneously, animals that tolerate human proximity, sheep, goats, cattle, pigs, chickens, become more docile under human influence. The domesticated world is co-produced. Humans alter ecosystems, and those ecosystems in turn alter human life histories. Settlement follows storage like a shadow follows a body. When surplus accumulates, grain in pits, dried fish in racks, stored tubers, the lure of staying near that store becomes undeniable. Houses cluster around granaries and water sources, hearths become persistent, centers of processing. Architecture changes from ephemeral shelters to more permanent structures. Mud, brick, timber, and thatch become materials for roofs that will shelter many sequential generations. The smell of pottery-fired earth joins the habitual aromas of smoke and baked loaves. A village is, first and foremost, an economy gathered in place. The social effects of such concentration are profound and immediate. Where mobility had leveled differences, nomadic life tends to favor egalitarian forms because possessions are costly to transport. Sedentism creates the conditions for differentiation. Some people become keepers of seeds and stores. Others specialize in weaving, flint knapping, boneworking, or pottery. Labor is divided not merely by age and sex, but by skill and tradition. Specialization raises efficiency and produces objects of workmanship that carry social signals. A finely woven textile, a carved comb, an intricately thrown pot. Those objects, in turn, become tokens of reputation and identity. With storage and specialization comes obligation. Surpluses invite redistribution. Food is given to elders and the infirm, portions are set aside for ritual, tribute may be collected for communal projects. The mechanics of such redistribution demand rules. Who may take, when, and how much. Rules require enforcement, and enforcement requires personnel or systems to track compliance. Out of these quotidian loops arise the earliest forms of hierarchy, individuals or groups whose role it is to manage stores, to adjudicate disputes, to coordinate labor for irrigation or repair. Authority is not always coercive at first. It is often practical. Those who remember where to find seed, who can read the season, who can measure water flow. But practical authority shades into social prestige, and prestige can calcify into power. Trade is the next logical expansion. A village that produces more than it needs becomes a node in a wider network. Obsidian is sought for blades. Marine shells travel inland as personal ornaments. Pigments move across valleys, and excess grain is exchanged for cloth or metal. Trade maps, human connections onto landscapes. It creates roots and relationships that are not strictly kin-based. It cultivates trust across distance and stimulates the circulation of ideas. Techniques diffuse by trade as much as by migration. A pottery style travels as easily as a seed variety. With exchange comes the need to manage promises and to record obligations. And here, the cognitive leap tightens into a technological necessity. Accounting. Human memory, tribal and robust, begins to be augmented by material systems of record. The first tokens, clay pebbles shaped into marks for sheaves or animals, are pragmatic tools. They are not yet writing in the modern sense, but devices that externalize inventory. Over generations, the shorthand becomes more complex. Impressed tokens give way to wet clay tablets marked with incisions. Pictographic signs condense into conventional marks. What begins as bookkeeping evolves into script. The first persistent scripts, as the archaeological record makes clear, originate in the mouths of administration. Records of rations, lists of workers, logs of deliveries. The need to coordinate labor across seasons and to adjudicate claims about who produced what drives abstraction. To write a name or a quantity is to fix a social fact outside any single memory. Writing transforms temporality. Obligations can now be deferred. contracts enforced, and promises transferred across hands and years. Alongside script come laws. Law arises where complexity and asymmetry multiply. When fields are irrigated by communal systems, when property is delineated, when labor is mobilized in projects that benefit some more than others, social norms require codification. Early codes. Rudimentary stipulations about theft, debt, and compensation are not philosophical treatises, but pragmatic answers to recurring social dilemmas. They formalize sanctions and remedies, and in doing so, they institutionalize inequality as much as they stabilize cooperation. A written law is a public memory about acceptable behavior. It anchors expectations in a form that can be called upon even by strangers. Cities grow from these knots of storage, craft, trade, and administration. The urban scale concentrates knowledge and talent. If a village is a workshop, a city is a campus. In cities, specialists cross-pollinate. Metallurgists exchange alloying tricks with potters experimenting with kilns. Mathematicians, practical men and women of measurement, calibrate field boundaries and architect monuments. Astronomers chart seasonal cycles that become the scaffolding for calendars guiding sowing and ritual. Monumental architecture appears not only as an expression of power, but as a communal signal. Granaries, temples, and palaces declare a capacity to marshal labor and resources. They are both practical and symbolic, storing grain, honoring ancestors, and framing civic narratives about origins and authority. Intellectually, this period sees a concentration of tools for abstraction. Numeracy grows because irrigation and taxation demand it, surveying requires geometry, calendars demand astronomical observation and prediction. Metallurgy opens new material vocabularies. Copper, bronze, and later iron change the shape of tools and warfare. The capacity to alloy metal is not simply a craft skill. It is a technical algebra that requires ratios and controlled operations. Mathematics and standardized weights let commerce proceed beyond gut feeling. Institutions of learning, temples, schools, workshops begin to transmit specialized knowledge across generations in ways that accentuate cumulative culture. A scribe's training, a craftsman's apprenticeship, an astronomer's long-term observations, each becomes a repository for refined cognition. Yet there is a shadow side to this intensity of intellect. Administrative systems that enable surplus extraction and redistribution also enable coercion. Monumental states mobilize armies. They project power beyond subsistence needs, sometimes to secure trade routes, sometimes to extract tribute. The division between those who command and those who labor hardens into class. Hierarchy codifies access to resources. Land, water rights, and political voice concentrate among the few. Religion often interlaces with power, offering cosmologies that justify rule and ritual that recompense obedience. Civilization's apex, measured in technical complexity, literary sophistication, and architectural scale, coexists with intensified inequality and ecological re-engineering. Trade networks grow into long-distance systems that knit continents in ways unseen before. Lapis lazuli from distant mountains appears in the ornaments of elites across seas. Tin for bronze travels across treacherous routes. Written correspondence transmits decrees and treaties across kingdoms. With these networks, cognitive styles diffuse, numerical notation, legal forms, and religious ideas cross borders. Empires try to standardize weights and measures, to unify calendars, to consolidate power. Bureaucracy, the art of administering many people at scale, becomes a human technology as consequential as the wheel or the plow. The pinnacle of human intellect in this arc is not a single apex, but a composite, the coordinated system that links observation to record, to institution, to law. Writing externalizes memory. Law externalizes ethics into enforceable rules. Architecture externalizes social order into space. Ritual externalizes emotional life into repeatable practice. Together, these inventions create a world where humans can plan multi-generational projects, sustain complex economies, and accumulate cultural capital that composes legacies. And yet, when viewed from deep time, even the tallest monuments are fragile. Cities collapse, empires fragment, writing systems fade into illegibility. The cognitive peaks of one era can be erased by climate shifts, war, or simple neglect. The fall of a capital scatters its artisans, texts crumble, knowledge is lost. In the vast geological ledger, civilizations are luminous but ephemeral phenomena. Intense bursts of innovation and social intensity that occupy only narrow slivers of planetary time. Emotion threads through all of this. The communal world of early farmers is saturated with affect. The anxious calendar watcher who eyes cloudless skies in the season of planting, the relieved chorus at a bountiful harvest, the resentful murmur of those excluded from stores, the awe at inscriptions that make names and obligations stick in clay for indefinite time. Pride lives in the craft of a potter whose forms travel distant trade routes. Fear underlies the construction of walls and the writing of laws against theft. Love and obligation shape kin networks. Grief is ritualized in increasingly elaborate mortuary practices. These are not theatricalized emotions, but the everyday feelings that make contract, law, and temple meaningful. There is also a philosophical tension that runs through the long human experiment. The same capacities that allowed cooperation at immense scales, external memory, symbolism, and institutionalization also made possible large-scale exploitation of environments and concentration of power. The intellect that devised calendars and drainage channels also devised tribute systems and war technologies. Civilization's apex is thus ambivalent. It is an achievement of distributed cognition and collective foresight, and simultaneously a source of novel vulnerabilities. Disease spread in denser populations, ecological degradation from intensive agriculture, social brittleness when institutions fail. From a deep time vantage, the most crucial lesson is neither celebratory nor condemnatory. It is empirical. Human beings developed techniques for extending memory and intention. Beyond the limits of single lives, they invented systems, writing, law, bureaucracy, that allowed many minds to be coordinated across time and distance. Those inventions altered the planet's biogeography and reshaped human biology, demography, and thought. They produced libraries, calendars, philosophies, mathematics, and art. They also produced inequality, conflict, and environmental pressures whose consequences echo to the present. At the close of this long arc, the narrative folds back into the question with which it began. What does it mean to be small and temporary on a planet that can, by human hands and minds, be reoriented? The soundscape of settled life, the clatter of pottery, the scratch of stylus on clay, the drone of markets, the chant of ritual, speaks of accumulation and of care. It speaks of people laboring to make the future legible, to bind social life into rules and records that will outlast them. That legibility is a double gift. It allows planning, learning, and cooperation at unprecedented scales, and it makes human actions consequential in ways they never were before. Viewed across 12,000 years, the transition from sowing seeds to writing laws is not merely technological, it is cognitive. It is the externalization of trust and memory, the invention of public facts, and the scaling of moral imagination. To plant is practical. To codify obligation is conceptual. The full arc of human becoming, then, is this entwined story of bodies learning new postures toward the fields, toward the city, toward one another, and minds learning to hold futures in common. In that shared holding is both the greatest power humans have ever exercised and the greatest responsibility they have ever borne. The planet, indifferent to any single species' destiny, nonetheless carries the traces. Terraces carved into hillsides, clay tablets with ledgers and prayers, libraries of stone that sing in vanished tongues. Those traces ask the same question they always have: what will be kept, what will be allowed to vanish? And they leave to the present the task of answering, with thoughtfulness, urgency, and humility.